Welcome to the Microsoft Fabric Notebook Data Engineering Masterclass. My name is Aleksi and I will be a teacher in this masterclass. And I will be teaching you how to use notebooks in Microsoft Fabric for data engineering. After going through this masterclass and doing all the tutorials with me, you are well on your way of mastering the notebooks in Microsoft Fabric. Before we get started, I would like to give a brief introduction to me and the contents of this masterclass. Let's start with me. I have been working with Microsoft Data Platform Stack for over 5 years now, and currently I'm working for a top-tier Microsoft partner company with headquarters in Finland that provides state-of-the-art data platforms using Microsoft Data Platform Stack. In my current role in the company, I work as a solution architect and a team leader for data engineers and architects. My personal day-to-day job still involves quite a lot of data engineering with Microsoft Fabric and Azure's data platform stack, and thus I'm very familiar with tools in both of those stacks. One of my favorite tools over the years have been Spark notebooks that can be found in multiple different services and platforms like Microsoft Fabric, Databricks, and Azure Synapse Analytics. I've been using notebooks daily for past 5 years now, and during those years I have accumulated a lot of knowledge and know-how about notebooks and their usage for data engineering that I want to share with you in this masterclass. And now let's talk a bit about the contents of this masterclass and what kind of topics you will be learning in this video. This video is broken down to 15 smaller lessons, and every lesson teaches you a new topic about notebooks in Microsoft Fabric. All of these 15 lessons except the first lesson are older videos that I've already published on my YouTube channel and now combine them to this one notebook data engineering masterclass. It is good to keep in mind that these lessons build on top of the previous lessons, and it is highly recommended to go through this in order. However, if you'd like to skip some of the lessons or only watch a specific lesson, you can do so easily by using the timestamps that I have added to this video. Now let's go through a brief overview of the lessons we have in this masterclass. In the first lesson, we cover the overview of the notebook as a data engineering tool in Microsoft Fabric. Then in the second lesson, we will go through NotebookUtils, that is this very useful library of tools that allows doing many different operations in notebooks, like managing secrets and running other notebooks. In the third lesson, we will learn how to process different types of CSV files. Then in the fourth lesson, we will cover using parameters and exit values with notebooks and how information can be passed in and out from the notebook by using them. In the fifth lesson, we will cover different ways of using SparkSQL in notebooks for transforming and exploring data. The sixth lesson focuses on explode function that can be used to flatten out arrays of data that can be commonly found in semi-structured data types like JSON files. And after we have mastered the explode function, we are going to apply those skills in the seventh lesson, where we learn how to process JSON files with notebooks. In the eighth lesson, we will dive deeper into running a notebook from another notebook and learn some new ways of doing it and what kind of things need to be considered with those methods. The ninth lesson teaches us the basics of fetching data from an API using a notebook, and in the 10th lesson we are going to expand that topic and learn how to parallelize those API calls for more efficient and faster processing. Even though this masterclass is mostly about PySpark notebooks, in the 11th lesson we will learn about T-SQL notebooks that can be used to interact with Fabric data warehouses and also Lakehouse's T-SQL endpoints. 12th lesson is dedicated to processing Excel files that can be sometimes a real pain for data engineers, but in that lesson we will offer an excellent painkiller for that pain. In the 13th lesson, we will learn about vanilla Python notebooks that are not using Spark engine and how those can be used to interact with Fabric objects like lakehouses. The 14th lesson teaches us the concept of metadata-driven notebooks that can enable us to build more configuration-based logic that can significantly boost the development speed. And in the last session, we will learn about different ways of handling schema drift, meaning handling new and missing columns in the incoming files and tables. Also keep in mind that all the materials that you need to follow along with the tutorials can be found by clicking the link in the description. But now, without further ado, let's start with the lesson 1. Welcome to the lesson 1 in this Microsoft Fabric Notebook Data Engineering Masterclass. In this lesson, we will cover the introduction and the overview of the Notebook tool. The goal of this lesson is to familiarize you with this tool and the different features that can be used for data engineering purposes. In this overview/introduction, I will go through many different features and topics about notebooks that we will be covering in way more detail in the later lessons. So don't worry if everything about the notebooks and their usage is not entirely clear after watching this first lesson, since we are going to come back to many of those topics. But now enough talking, and let's go to Fabric. Now we are in Fabric, and I have this blank notebook open here. And your first question might be, what is a notebook? Basically, notebook is this very flexible and interactive code-based data engineering tool that is meant for data transformation and data exploration. And since notebook is a code-based tool, it has a bit steeper learning curve than those low and no-code tools that are also available in Fabric, like data pipelines and data flows. But notebook has also a lot of advantages over those no and low code tools, because it has way more flexibility compared to those tools, since you can write your own code here. And I typically like to refer notebooks as this Swiss Army knife of data engineering, since you can pretty much do all the things with notebooks. But it is good to keep in mind, even though you can do almost everything with notebook, in some cases you should not do everything with the notebook. For example, with the data flow and a data pipeline, you have many great built-in connectors to different source systems that can be used very easily, and you don't have to write code logic for using those connectors. So in those cases, for example, the data pipeline and data flow tools can be superior compared to notebooks. And as we can see from this UI, we have this PySpark notebook open. And in Fabric, we have possibilities to create another kinds of notebooks as well. Firstly, we have many different languages available for Spark. And what is Spark, you might ask? I'm not going to dive very deep into what is Spark, but basically you can think about Spark as this very powerful data processing engine that processes things in parallel. In my opinion, one easy way to explain what is Spark is to say that, for example, we have order of 1000 pizzas. If only one chef would create all of those pizzas, it would take a very long time. But instead of one chef, we have multiple chefs working in parallel that are creating those pizzas, and before we deliver the order, we will bring those pizzas together. That is basically how Spark works. So in a Spark cluster, we have many different nodes or computers that process data, so we don't have to use just one computer for data processing, and we can distribute the processing and make it faster that way. And for Spark, there are many different supported languages. For example, we can use Python, Scala, SparkSQL, and R. In this masterclass, we are mainly going to focus on Python and SparkSQL. Then in Fabric, we can also create Python notebooks. These are basically Python notebooks without Spark, so we don't have that overhead of running a Spark engine on the background, and we can use smaller compute to run those notebooks. Then we can also create T-SQL notebooks that use this Microsoft dialect of SQL called Transact SQL, or commonly abbreviated as T-SQL. These T-SQL notebooks are meant to interact with Fabric's data warehouses and lakehouses T-SQL endpoints. And we're going to check out those T-SQL notebooks later on in this masterclass. And also we are going to come back to those Python notebooks, but the main focus is going to be in the Spark notebooks, and more specifically in PySpark notebooks. And now let's add some code to our notebook so I can demonstrate how the development work happens here. And here I have some code that will create this data frame. And you can ask, what is a data frame? Basically, data frame is this collection of data that is organized to rows and columns, like a table in the database or an Excel spreadsheet. And these data frames are a very convenient way of interacting with Spark, since they handle most of the complex tasks under the hood, so you don't need to care about optimizing things by hand here. So data frames are already optimized in many different ways by the Spark engine. Also, a good thing to note that if we want to execute any code and run any code here, we need to start a Spark session. So we can connect this notebook to a Spark session here and start a new session, and then we are able to run the code here. And this will basically kickstart a computer or a cluster on the background that we can then use to run the code in our notebook. And now the session is starting, and now it has started, and we can run our code here and see what kind of data frame this code will produce. And basically you can already see it from the data pretty well here. But yeah, and here we have this simple data frame that was created by the code that I had here. And here we can explore our data in our data frame in the table format after we have displayed that data. But we have some other features here that we can also use to explore our data. One good way of exploring the data is by creating a new chart. And here we can create a chart out of our data and see how does the data distribute and customize our chart if we would want. These charts are a very convenient way of visualizing the data in some cases when doing the data engineering work to familiarize yourself what you're working with. But yeah, we're not going to dive too deep into these charts in this masterclass, but it's good to keep in mind that these charts are available here and you can use them whenever you want. Next, let's talk about these different tabs that we have here. And let's start with the Home tab. Here we have the possibility to save our notebook or download our notebook, and here we have some different formats that can be used if we would download this notebook. Then we have possibility to edit some notebook settings here, but here we don't have that much settings. Basically, we could rename our notebook and add some description or then endorse it or schedule our notebook, to which we are going to come back quite soon. But yeah, then we have this button to run our notebook, and here we can run basically all the cells in our notebook, or maybe run cells above our current cell or below our cell. And then we have the session button where I start that session previously, and then we can also stop that session here. Then we had that language selection where we can select the language that our notebook is using. And basically this sets the default language for our notebook, and we're going to come back how to use different languages in a notebook quite shortly. Then we have the possibility to select the environment where our notebook runs. And we can open up my test environment to see what kind of things we can manage here. Basically we can manage libraries here, so what kind of packages we have pre-installed in our cluster when it starts. Then we have some Spark compute settings here, so we can change the size of the Spark cluster that is running on the background. And keep in mind that if you create a bigger Spark cluster, it will consume more of your Fabric capacity. So you don't want to create a huge cluster there that doesn't serve any purpose. So basically you don't want to create a huge cluster and then just utilize a small part of the compute that you have allocated to that cluster, because that will eat up your Fabric capacity pretty fast. And after the environment selection, we have this data wrangler here that can be used to visually transform the data here. This is a cool feature that I don't like personally using that much, but this data wrangler would allow you to do these transformations here by just selecting things from this menu, what you want to do with your data. In some cases, this can help people who are not so good at writing their own code, and with this you can get started with some data transformations pretty quickly. But this is a feature we're not going to cover in detail in this masterclass, but I would encourage you to explore this feature on your own. And then we have a button to add a new auto machine learning run, or add this notebook to a data pipeline. That is another great data engineering tool in Fabric, or open up this notebook in a VS Code. Then we have the Microsoft's AI assistant Copilot here as well available for notebook. This will require some prerequisites that you have to meet before you can use this in your notebook. And I have already done a video about Copilot in Microsoft Fabric notebooks to my YouTube channel, and you can check out that video there. But basically this Copilot integration in notebooks would allow you to comment code and generate code by using an AI natively here in the notebook. It's a pretty handy tool, and I would encourage you to explore it on your own if you have the time. Next, let's go to the Edit tab, and here we can select if we have the autosave option on or off, and then we can undo and redo some actions, and then we can copy a cell, and then we can paste a cell, and then we can move cells up and down, and then we can delete a cell, and then add some cells here, and then we can also clear our cell outputs. For example, if I would press this clear cell outputs button, this would disappear here like this, and then we can run that again to display that cell output here. And then we have a very cool feature here in the notebook, this browse code snippets. And if I click this, it will open up these pre-made code snippets that Microsoft is already providing to us. And here we can find plenty of code snippets for many different languages here in the notebooks. Here we have, for example, some NotebookUtils code snippets that would allow us, for example, move a file from one location to another. And then we have plenty of other code snippets here as well, like lakehouse interaction and how we can read data from a delta table or write data to a delta table. Here you can find code snippets for many different basic code operations that you would be doing in a notebook. And then you can just insert the snippet that you want to a notebook by clicking this insert button, and then it will add that to your notebook. But I will delete this for now because I don't need this right now. I would really recommend to keep this code snippet functionality in mind when developing notebooks, because this is a very helpful place to get some code very quickly to your notebook. And then we have this functionality to find and replace things in our notebook. Then next we have the Run tab, and here we can run our notebook, and here we have some same buttons that we had already in the Home tab, and also the possibility to add this to a pipeline, and then we can schedule our notebook. And let's talk a bit more about this scheduling feature. Basically, we can decide a schedule for our notebook when we want to run it. For example, if we want to run it hourly, for example, every 1 hour, and then we can define the start date and time and end date and time for our notebook. And we have also the possibility to select the time zone where our notebook is going to run. So the start date and time and end date and time will be using that time zone that you have chosen. But yeah, I'm not going to schedule this notebook right now, so we want to discard the settings here. And then if our notebook has run already, we can view all runs here and see how we have been running that notebook previously. And here I have done some test runs before this video, and we can see those here. And in this View tab, we can first change our layout from the standard to side-by-side or outputs only, but I personally prefer to use the standard layout here. And then we have this table of contents here. And as we can see, this table of contents is now empty. But one cool thing about notebooks is that it supports Markdown language, and we can add here a code cell or a Markdown cell. And if I select the Markdown cell here, we can write some Markdown language here. And now I'm going to add some Markdown to this cell, and now we can see that we have some Markdown documentation here. And now if we would open again the table of contents, we can see that this Markdown will actually create the table of contents for us. And then we can click here to which part of the notebook we want to hop by using the table of contents. So this is a good way to document the things and comment the things that are happening in the notebook, so that this notebook is easier for other people to use and debug if there are some issues. Also, we are able to add some images to this notebook as well that I use very rarely, but now I will drag and drop a Fabric logo to this notebook from my computer, and here we can see that now we have a Fabric logo in this notebook. Then after the table of contents, we have these variables here, and from here we can check what are the variables that have been defined in the current notebook run. And for example, here we can see the columns variable, since we defined some columns here, and then we have the data variable where we defined the data for our data frame, etc. But yeah, there you can check out some variables that you have been using in your notebook. And then we have these keyboard shortcuts that are very handy, and here we have some shortcuts that you can use when developing a notebook to do things a bit faster by using these shortcuts. And after that, we can toggle and untoggle the line numbers. I basically like to have these line numbers always on here. And then we have this What's New button where Microsoft will sometimes announce new things related to notebooks. And then here on the right upper corner we have this possibility to add comments to our notebook, and here we could comment things. For example, I write here a new comment and then I will send it, and now it is added there, and there we can see that that thing has been commented and we have that comment there. But I will now resolve that thread and maybe delete that comment. But this comment feature is a cool little feature that can be used if there are multiple people working with same notebooks. Then we have also this change history here where we can check out the changes that have been made to this notebook. This is a cool little feature, but in my opinion a bit irrelevant, since in a real world scenario you would like to have these notebooks in a version control and version control integrated to Fabric. So you would have your commits in the version control and you would explore them that way. But yeah, it is good to keep in mind that this keeps a log about the changes that you have made to your notebook. And next, let's add a new code cell here. And as we can see, this code cell is now by default Python or PySpark cell, since we are using PySpark as the default language for this notebook. And there are some magic commands in the notebook that we can use to change the language in a specific cell. For example, if I would like to use some SparkSQL here, I would add this %SQL here, and then I would be able to write SQL code here. For example, select 1 as A. And then we have some SQL code here. And now we would be able to execute this and we would get the result here as well. Another way we can do that is by using this selection here. And for example, select Spark Scala, and then it will add the appropriate magic command in the beginning of cell. And now we would, for example, be able to change it to SQL or maybe Spark R. And then we would be able to add some R code here, for example, like this. And now we have some Spark R code here, and then we would execute the R code. And there we can see that we managed to execute some R code in our PySpark notebooks by using this magic command. And like you probably know, there are other items and tools in Fabric as well. And one of the main items or data stores that is being used to interact with notebooks is the lakehouse. And here we can attach a new lakehouse to our notebook. And here we can click add and add an existing lakehouse with a schema and select the lakehouse that I will be using in this masterclass to do the demos. And we have to stop the session when we are attaching a new lakehouse, and now it is attaching that lakehouse, and then we can start a new session. And now the lakehouse has been attached, and there we can see all the table schemas that we have there and all the folders that we have for the files. And now we can start a new session for this notebook, and then we can start query our tables in our lakehouse. And there are some quick ways that we can use when we want to query things, for example, in our table section. And we can just drag and drop, for example, this animals table to our notebook, and it will actually create the necessary code that is needed to fetch data from this table here. And now I will be also displaying this animals data, but this code was pre-created by Fabric when I just dragged and dropped that table to our notebook. And it should be done very shortly since we're just querying this small amount of data, and there it is. But yeah, almost all of the tutorials that we will be doing are considering lakehouse, so I'm not going to dive too deep into this lakehouse interaction in this video. Then we have some other magic commands in notebooks that is good to be aware of. For example, here we have a magic command for pip that is this Python package manager that can be used to install Python libraries like pandas. And if we would run this, it would start to install pandas to this notebook, even though pandas is already available. But with pip, you would be able to install libraries that you have not defined in your environment or are not pre-installed to your cluster already. Then we have also a magic command sh that would allow us to run these shell commands using our notebook shell. And here I'm just listing the directories, and here we would be able to modify and do operations in the Spark cluster file system by using this magic command. And this is something that is a bit more advanced but could come in handy in some cases. Then we have also a magic command for running other notebooks, and this is one way to run a notebook inside this notebook. So we can say this %run, and then we define the notebook name that we want to run. And if I would run this, then it would run that notebook. And the notebook that I just ran was this another example notebook where I just defined one variable and print it. And here we were able to see that we just printed that ABC that was defined in that notebook. And like I said, notebook can be used to interact with other Fabric items like lakehouses and other notebooks. And personally, I like to use these notebooks as part of my data pipeline. And we can interact with notebooks in a data pipeline. So let's go to this Create tab and let's create a new data pipeline here. And let's hit Create. And to our data pipeline, we can actually add this activity that would allow us to run that notebook. So let's select the pipeline activity here, and we can find the notebook here, and there we have the notebook, and we are able to add the notebook activity to our data pipeline. And here we can define which notebook we want to run. So if I would select the Masterclass example 2. That was the other notebook that just printed ABC. And here we would be able to also define some parameters for our notebook. So pass data from the data pipeline to notebook, but we are going to come back to these parameters later on in this series. Also, we would be able to define some exit values in our notebook and pass information from the notebook back to the data pipeline. But that is also something that we are going to cover in a later lesson in this masterclass. But personally, I don't like scheduling individual notebooks, and I like to run them as part of my data pipeline and data processing logic. And in my solutions, I usually use data pipeline for data pipeline orchestration and then have some other activities here that are run in this kind of a logical order. But yeah, now I have covered this very brief overview to a notebook as a data engineering tool, and in the later lessons we are going to dive very much deeper into the topics that I just mentioned briefly in this video and cover other topics that were not discussed in this video yet. I hope you now have a general understanding what is a notebook and what it can be used for. Today we're going to check out NotebookUtils that allows you to do many essential things in notebooks. If you're familiar with Databricks notebooks and using DB-utils there, this functionality is very similar to that. Also, NotebookUtils was previously called SparkSQL. That still works, but that namespace will be deprecated at some point. But now enough talking, and let's open up Fabric and check out the operations that NotebookUtils allows you to do. Now I have my example notebook here open that I have prepared to demo the functionalities of NotebookUtils. Let's start by running this help command that will give us more information about NotebookUtils. Basically, NotebookUtils can be divided to these 5 groups of commands or functions that can be used. First, we have these notebook utilities that will allow you to do some notebook operations, like run other notebooks within your notebook. Then we have the lakehouse functionalities that will allow you to create, delete lakehouses or get some information about lakehouses. Then we have these FS or file system functionalities that will allow you to do some file system operations like create new directories, copy files, and so on. Then we have the credential utilities that will allow you to fetch some secrets from Azure Key Vault or add some secrets there. And lastly, we have these runtime utilities that will allow you to get some information about your notebook runtime. And next, we would go through all these sections here and demonstrate few commands per section so you get an idea what kind of commands there are and what kind of things you can do with these commands. Let's start with these file system operations, and let's run this help command for the file system to see what kind of commands we have available. And under this FS or file system operations, we have these many different commands that can be found. And you can see that these are very similar to your Unix commands if you're familiar with those. For example, we can copy files or then use fast copy to more efficient copy that will then use AC copy on the background. We can move files, we can list contents, etc. Basically, this will allow you to manage file systems in your notebooks. Also, if we would like to get more information about specific command, we can run this help command for a specific method here. For example, we can run this for the fast copy or fast CP command, and then we will get more information about that command and what kind of parameters it will take. But now let's demonstrate a few of these commands next. Let's start with this ls or list command and list our file section of the lakehouse that I have attached to this notebook. And here we can see that we have there only one folder called demo folder 1. And we can see that also here in the UI. And then we can use the make dirs command to create another folder to that lakehouse. And now if we would refresh this file section, we would see another folder there. And I can show to you that we have some files here in our first folder, animals.csv and movies.csv. And now we can demonstrate the copy command and copy one of those files, the animals.csv, to our new demo folder 2 using the copy command. Let's run this one and let's see what happens. And it went through fine. And now in the demo folder 2, we should have, yeah, there is the animalscopy.csv file there. Also, a good thing to note here that these commands are not limited to Fabric data stores like lakehouses. And we can use these to get some information and do some file system operations in Azure Blob Storages as well. Here I'm doing this list command to a blob storage that I have in Azure. And there I have this container called data lake, and in that container I have this folder called temp, and in that temp folder I have this one file. So let's run this list command and see what it yields. We can see that we get that file that we have there as a result. And next we could see what is the content of that file using the head command. And we can see that it just said I'm a file in Azure Data Lake. Also, I have to note when running these commands to Azure Blob Storages, you need to make sure that you have a sufficient access to that blob storage, making sure that you have, for example, blob data contributor rights to that blob storage. Next, we can move to section 2, where we cover these notebook functionalities of the NotebookUtils. Let's run the help command to see what kind of functions we have here. We have, for example, an exit function that will allow us to specify an exit value for notebook. And then we have these run functions that will allow us to run some notebooks within our notebook. And then we have some preview functions that are quite new to these functionalities. For example, creating a notebook, getting some information about the notebook, deleting notebook, and etc. First, let's talk about the exit function, and let's run our help function for our exit function and see what it says. This method lets you exit a notebook with a value, and a parameter we have to provide a value that we will be returning when the notebook runs. And under here I have this exit value here. We can run this and see what happens. Basically this just says that the exit value for this notebook was now some string value. And now I want to talk a bit more what we can do with this exit value. For example, if we would be running this notebook as part of pipeline or maybe some other notebooks, after that notebook has executed, we would be able to return this exit value to that pipeline or notebook. For example, here I have a pipeline where I have ran a notebook with an exit value, and this exit value will be shown in the output after the notebook has succeeded. So we can check out the output, and here we can find this property called exit value, and here we have the value for that property. So this will allow us to return some information from the notebook to the pipeline or, for example, another notebook. So this will enable you to do some logic based on that. Next, let's check out the run command of the notebook functionalities, and let's run help function for that. Basically, this command would allow you to run a notebook within your notebook, and let's check out how this works. And under here I have the example how we could use this run function to run one notebook within this notebook. So first we provide a path to that notebook. That is basically the notebook's name. Then we provide the timeout for that notebook, how long we would wait that to run. So I have provided here 60 seconds. And then we can give some parameters to that notebook if we have defined parameters in that notebook. So here I'm passing this hello world parameter to that notebook. And then of course we are also catching that exit value that would come out from that notebook if we have defined exit value inside that notebook. But this time I have. So let's run this and see what happens. Now this command is running and it should only take a little while to run. And now that notebook has executed, and we can also view that notebook run by clicking this link that will actually take us to that notebook that we ran. And we can see that we have defined some parameters there and we printed those parameters, and then we had this exit value here that we also received to this top level notebook since we printed that. Next, let's check out this run multiple function that will allow you to run multiple notebooks within your notebook. Let's first run this help for our run multiple function and let's see what it returns. This help function returns quite a lengthy explanation for our run multiple since this is a quite complex function, but we will get into that shortly. But basically we have two options. We can either define this array of notebooks that we want to run, or then we can define this DAG that is a bit more complex way of running notebooks, what will allow us to do more complex stuff that we will get into shortly. Let's first demonstrate this simple way of running two notebooks using this array. So basically as a parameter, we just define an array of notebooks or notebook paths that we want to run, and then we just run multiple command. And now it will kickstart those notebook runs that should finish very fast, since I don't have much happening in these notebooks. Now they have succeeded, and we can see that both of those notebooks had these exit values that are also brought to this top level notebook. Next, let's move forward and let's cover that more complex way of running this notebook using this DAG. Here we have to define this DAG, and in this DAG we would define different properties per notebook. First, we could define the notebook name, and then the notebook path, and then the timeout for those notebooks, and the amount of retries that it will try to retry that notebook if there are any errors. And then we define also the retry interval, and we can also pass parameters to these multiple notebooks using this DAG. Then I have some other notebooks defined to this same DAG as well. So basically in total I have 3 notebooks here. And cool thing about this DAG that it allows us to do some dependencies between these notebooks. For example, I can say that this notebook 3 is depending on the notebook 2. So this notebook 3 run won't start before we have completed this notebook 2. Also, we can define this kind of a total timeout for all of these notebooks and concurrency, how many notebooks we want to run in parallel. Next, let's run this run multiple function using this DAG that I have defined here. Also, let's set this display DAG via graph width to true. That will then visualize this whole notebook run that we can see shortly. But yeah, let's run this and let's see what happens. And now it will start running these notebooks. And since we have defined that dependency, that notebook 3 will actually wait until this notebook 2 has succeeded. But now they're running. Now all of our 3 notebooks have succeeded, and we also get that graph because I added that property to visualize this notebook run. And we can see that there is a dependency between these 2 notebooks in this visualization. Also, we got those exit values to here as well. Then we can check out this list function that will basically just allow us to list all the notebooks in our workspace, and we can run that to see what kind of output it will yield. Basically, we get here a long list of all the notebooks that I have in this workspace. Then we can use this create function that will allow us to create some notebooks, and here we have the parameters that it will be expecting. First, we would have to give a name to our notebook, then a description, and then some content, and then the default lakehouse and default lakehouse workspace and workspace ID. But basically many of these have empty string as default value, so we don't really need to specify them. And here I have some notebook contents that I would like to use to create another notebook. And if you're interested in how to get this kind of a JSON that will describe a notebook, you can go here to this download as and select this notebook format here. That will be then this JSON format that you can then use to create notebooks based on that. And now let's use this notebook definition here to create a new notebook based on this. And let's run this command here to create that notebook. Now our create function has run, and now we can try to find this notebook that we just created by browsing it from our workspace. There it is, and we can open up that notebook and see what kind of content it has. Basically, this is the notebook that we just created, and we already defined all of these things that we have here in that notebook definition that we had there. Basically, there is the cell with that exit value, and there is that cell with that print function. But yeah, this is the way how you would be able to create notebooks based on this notebook definition. And next, we could use the delete function to delete that notebook. Let's run this help function here. So basically, we would have to provide the name of the notebook for our delete function in order to delete it. And here I have the delete function, and I would like to delete the notebook that we just created using it. And let's run that. And now it has already finished and returned true. So basically now it has deleted that notebook that we just created. Next, let's move to section 3. In the section 3, we have these lakehouse utilities. And let's run first this help function to see what kind of commands we have. This is a preview functionality since these lakehouse utilities are quite new. We can, for example, create a new lakehouse, get some information about our lakehouse, update our lakehouse, delete our lakehouse, or list our lakehouses in our workspace, or list some tables that we have in those lakehouses, or load some data to a lakehouse table. And next, let's first use the list function to list our lakehouses that we have in this workspace. As you can see, I have quite many lakehouses, and we get some basic information about those. We can use this get function to get the same information about one single lakehouse when we specify that lakehouse name as parameter for our get function. Then we can expand the information that we get with the get function using this get with properties function, and then specify the lakehouse that we want to get that information about. And here we get bunch more information about the lakehouse, like some one lake file paths and default schemas, etc. Next, let's move to the section 4, where we cover this credential functionalities, and let's run our help function. And with these credential functions, we can, for example, fetch some secrets from Azure Key Vault, or put some secrets there. And then we have some other functions like getting some tokens or validating some tokens. Let's first cover the get secret function that I think is one of the most used functions here. Basically, for the get secret function, we want to provide the Azure Key Vault URL, and then we want to provide the secret name that we want to fetch. And also, good thing to note here that you need to make sure that you have sufficient access to that Key Vault when fetching secrets from there. For example, you have the Key Vault secret officer's role added to yourself to that Key Vault. Then you will be able to fetch some secrets out from the Key Vault. And now let's run this and let's see what happens. As you can see, we managed to fetch that secret value out from the Key Vault because this didn't throw any errors. However, we cannot print that secret value directly to this notebook output, since the Fabric tries to make sure that the secrets are not exposed, and it adds this redacted print if we try to print that out. However, there are a few workarounds if you really want to print that secret out to the log. That is not recommended. For example, we can first turn that secret value into a list, and then we can print that out like this. And here we can see what is the secret value there. That it just says extremely secret value here, exclamation mark. Next, let's move to the section 5, where we have these runtime functions. And let's run first the help function to see what kind of functions we have here. At this point, we only have this context function that will get the current runtime context. And we can run that context function and see what kind of output it will yield. Here we can see that we get some information about the context of this notebook. For example, the notebook name, default lakehouse ID, parent run ID if we would run this as part of another process, etc. There are maybe some use cases where you could use this to build some logic based on this, but this is some cool information that is good to know that it is available via this context function. Now let's open up Fabric and check out how to read different kinds of CSV files using notebooks. Let's start from my lakehouse, where I have created this new folder Fabric DE Series 23 under the file section of the lakehouse. In this folder I have two CSV files, movies1 and movies2.csv. We will start with the movies1, so let's check out the contents of that CSV file. This CSV file has a really standard content with a header and few rows of data separated by commas. Next, we would like to read this CSV file to lakehouse table using a notebook. Here I have a blank notebook, and I've already attached this notebook to the lakehouse that I just showed to you. And we can also navigate to that same folder using this notebook view here. But now we would like to read in this movies1.csv to a delta table. We can start by adding a new code cell here. And here I have some code that would read in a CSV file from that location. And let's break down a bit what this code does. Basically, we are loading in a CSV file from the path that I have specified here. And that path is pointed to this folder and that movies1.csv file. And then we would like to display that data frame that comes as a result of that code. So let's run this and see what happens. This should finish really fast. And now it is already done. And we can see the data here, but it is not correct yet. We can see that our header is now on the first row of data, and as a column names we have this underscore C0, C1 and C2 columns. This is not the result what we want. So basically we would like to tell to this read function here that we would like to use a header when reading that CSV file, so that these would be the column names. So let's do that. And here I have a more refined version of that code. And here we are giving this option header true to this function when we are reading in that CSV file. And then we're again displaying that data frame that comes out from that CSV file. Let's run this and see what happens. And we can see that this looks now a lot better. We can see that we have that header in place and then we have those rows of data there. Now we could actually write this data frame to a lakehouse table. I will add a piece of code here at the end of this cell that will do that writing for us. And with this code, we can read in that data frame to a delta table in our lakehouse. So basically, we are using the data frame that we just read in. Then we are telling to Spark to write it and using the mode overwrite, which means that we would overwrite the data if the table already exists there. And then the format of the table will be delta. And then we are going to use this save as table function and give our table the schema and the table name, where that table would go. And now let's run this and let's see what happens. This could take a little bit longer since now we are creating that table also. Actually, this time our code didn't work because it cannot find the schema that I have specified here. But we can go to our lakehouse and create that schema for us and then that code should work. So let's go here and click new schema. And let's give our schema a name and then hit create. And now we have that schema in place. So let's try to run this again and let's see what happens. Can we write it there now? And now it went through fine and we should have that new schema here with that new table under that schema. And there we have that movies one table. So now we have managed to read in our first CSV file to a lakehouse table. Next, we would like to read in our second CSV file. Let's go back to our lakehouse and let's check out the contents of that second CSV file. As we can see, the data in this CSV file is exactly the same that we had in that previous file. But now we don't have a header and now we are separating our records with this semicolon here. So let's go back to our notebook and let's check out how we can read in this CSV file. Let's try to read in this CSV file without specifying any options and let's see what happens. Now we can see that all our data is in 3 rows, that is correct, but all the data is in 1 column, that is not correct. So now we would need to tell the Spark to use this semicolon as separator when reading in that CSV file. And next, let's do that. And here I have the code that would give this option delimiter to this CSV file reading function and tell it to use the semicolon as separator when reading in that file. Let's see how this would work. Now we can see that our data looks better. We have the data in 3 rows as it should be, and then we have also 3 columns as it should be. But our column names look a bit funky since these are the default column names that the Spark uses when there is no header for the CSV file. Here I have the code that would actually add the column names to that data frame when reading in that CSV file. Let's break this down a bit. So here we have that row that would actually read in that CSV file. We can see that we have that same option that we'd had previously, but now we also have this schema option. And this schema option is going to use this schema that we have defined here that would tell that we have these columns film, year, and rating. Also, we have to change the data type of this schema to this struct type in order to pass it to this schema because it doesn't read in this kind of a raw JSON schema. I will also print out that struct schema that we are creating here from that JSON so you can see how it looks. Also, in order us to get this code to work, we need to do a few imports. We are importing some types, so we get that struct type here, and also we import JSON, so we can use these JSON functions here. But now let's run this and let's see what happens. Now it is running. Now our cell has run and we can see that we printed this struct here that is basically describing the schema that we have here, but a little bit in a different format that is able to be used here in the schema option when passing it to this Spark read function. Also, as we can see, now our data frame looks correct, so we have that header in place and we have the rows correct as well. So next we could uncomment this write function here, so we would be able to write that data frame to a delta table. And now it is done and we should have another table here. And there we have movies_2. So now we have managed to read in both of our CSV files to these tables here in our lakehouse. Also, I want to show to you how you can generate this JSON schema here easily, if we would like to, for example, generate it from this data frame that we are using here. And this would be the code. So basically we're using that data frame.schema.json, and then we could run this, and as an output that will give us this schema that we have here. So this would be a very convenient way of generating that schema. Today we're going to cover running notebooks as part of data pipelines and how you can pass information from a data pipeline to a notebook and from a notebook to a data pipeline. Let's fire up Fabric and check out how to do this in action. Here I have a blank notebook that I'm going to use in this demo. Then we also have a blank pipeline here that we're going to use as well. Let's start from our notebook. Let's add these two parameters to our notebook called param1 and param2. And to the param1, let's add this value ABC, and to the param2, let's add that value 0. So basically, we're expecting to have string values to our param1 and integer values to our param2. And next we would need to navigate to this right hand side and here click toggle parameter cell. And here we could see that this cell has now chosen to be this kind of a parameter cell. A little bit later we can see how this works. And under this cell we can just add two print functions that basically are just printing our parameter values like this. So this first cell would be used to ingest some information that is coming from the pipeline to this notebook, and to the last cell we want to add a function that will actually return data back to the pipeline after the notebook has executed. And I have a function for that, and that can be achieved by using NotebookUtils, and there the notebook functionalities, and there is this exit function. And there we can specify the string value that will be returned from a notebook to a pipeline or whatever process is running this notebook as this kind of a return value from this notebook. And here we basically have all the code that we're going to need in this demo. So we're getting in some parameters, printing those parameters, and then we are returning an exit value after the notebook has completed. Next, we can move into our pipeline. And to this pipeline, we want to add a new activity and we want to add a notebook activity here. Let's name this notebook activity a bit better here, that it describes that we are running that specific notebook. Then we have to also select that notebook from the list of available notebooks here. And then we want to add two parameters since our notebook has these two parameters, param1 and param2. And our param1 is going to be this string type, and to the value we can just write, for example, pipeline value here. And our param2 we want to specify to be integer, and let's select that, and then we can pass a value, for example, 1, 2, 3 there. And now we have configured the parameters for our notebook. And now we're ready to run this notebook since we have configured the parameters and selected the notebook that we want to run. Let's run this and let's see what happens. Now our pipeline is running and it's going to take a little while to run this notebook. Now our pipeline has succeeded and we managed to run that notebook activity successfully there. And by clicking this activity name, we can get this more information about the execution. And we can click this notebook snapshot link here that will actually open a new tab, and here we can observe what happened during the notebook execution there. And in this view, we can see that we had two input parameters for this notebook, param1 and param2, and there are the values. And we can put this down there, and we can see that this was the original cell that we defined to be as this parameter cell. And when we were executing this notebook, Fabric actually generated this new cell under this parameter cell where it replaced these parameter variable values with these new values that were coming from the pipeline. And here is also a link that will explain something about this functionality. And now we can see, since we replaced the values of these variables, we are printing values that came from the pipeline here. Then we also have this exit value that is saying this is a return value from the notebook. And we can actually see this return value in the pipeline by going to the pipeline and checking out this output that we have here. This is actually a little bit hard to read, but we can see that there is this property called exit value, and there is this return value that is coming from the notebook. Let's close this output and let's add set variable activity to this pipeline. Let's select the set variable activity, and then we can add a new variable to this pipeline called NB exit value or notebook exit value. And let's have that as a string because that exit value is coming as a string from that notebook. And then we could use this set variable activity to here and use the dynamic content. And then we would set this variable value to be that exit value that is coming from the notebook. So basically the syntax would be the activity name dot output dot result dot exit value if you have specified that exit value in your notebook. And this should be able to fetch that exit value that is coming from the notebook. And now we can click OK and everything should be configured correctly. And now we can click run and see what happens. Now we have run our pipeline and we can see that everything went fine since all the activities succeeded. And now let's check out the output of our set variable activity. And here we can see that our NB exit value variable now has this value. This is a return value from the notebook. That is the same value that is coming from the notebook. And this is how you would refer these exit values that are coming from the notebook in the pipeline and how you could use to build logic around them. Today we're covering using SparkSQL in notebooks. I know that there are many people who are way more used to SQL and are maybe a bit afraid to use Python and PySpark to build data processing logic, but would like to use notebooks in their solutions. Well, I have some bad and good news for you. The bad news are that if you're planning to use notebooks, it is almost mandatory to learn the basics of Python and PySpark. Or the other option would be learn some Scala that I don't recommend that much. The reason is that SparkSQL is not flexible enough in most cases to get the entire job done. The good news are that it is very easy and convenient to combine Python and SQL in your notebooks, and they work very well together. So you don't really have to make a choice between those two. And that is what we're going to learn in this video. So let's jump into Fabric. Let's start from my lakehouse, where I have created this new folder called Fabric DE Series 25. In this folder I have this CSV file that we're going to read in to a lakehouse table and then query that using SparkSQL. In this CSV file I have some data about IMDb's top 1000 movies. Let's check out the contents of this file. And here we can see that this is a pretty long data set containing some data about movies. And we have multiple columns in this data set that we can use to query this data. But now let's go to our notebook. Here I have a blank notebook that we are going to use in this video to demonstrate how we can use SparkSQL in notebooks. But first let's read in that CSV file to a lakehouse table. Here I have a code that would read in that CSV file to a lakehouse table. First, we would create a schema to our lakehouse where we could store that table. Then we would read in that CSV file to a data frame, and then we would save that data frame to a lakehouse table called IMDb top 1000. Let's run this code. And now our code has run, and we can refresh our lakehouse in order to see that we have a new schema there. And in this schema, we have that table IMDb top 1000 that we can now use SQL to query. As we can see in the top bar, Python or PySpark is the default language in this notebook. Here we can see the other languages that are also supported in the notebooks. However, we can mix and match these languages. For example, now this is Python code, but if we would like to add another cell and write some SQL here, we can actually add 2 percentage signs and then SQL, and now we would be able to write some SQL logic to this cell. And here I have prepared some SQL that we can use to query this table. Basically what this query does, it selects the series title and renames it as title, and then the IMDb rating and renames it as rating, and also change the data type to double. Then we're also selecting only rows where rating is 9 or greater, and then we're ordering rows by rating. Let's run this code and see what happens. And here we have all the movies that have a rating of 9 or higher. Also a good thing to note here that there seems to be some type of bug in the Fabric right now, since I'm not getting the color coding to my SQL sentences that I'm usually getting here. Next, we could try to execute the same query in a little bit different way by combining Python and SparkSQL. Let's see how we would do that. Let's add another cell here. Here I have a code that would leverage SparkSQL as part of PySpark code. So basically we are using this spark.sql function, and then we are passing that exactly same query that we have there above as a string to that function. And then we can create a data frame out from that query. And then we will display that data frame in order to show you that we have exactly the same results as above. So let's run this and let's see what happens. Now our command has run, and you can see that we have exactly the same result, but using a little bit different syntax this time. So in this case, we don't have to use this SQL magic to run SQL, and we are running that in a Python shell. My biggest problem with this code here is that the SQL query is a bit hard to read, since everything is on one line. By using this kind of a line formatting, it's way easier to understand what's happening in the query. Luckily, we can do this same thing in this SparkSQL by using this kind of a triple quotation marks here. And this would happen in this fashion. So basically we would add these triple quotes, and then we would be able to add some line breaks to our string and format that a little bit better. Now you can see that our SparkSQL is now formatted better, and we can actually see better what's happening in this query. And we can run this query to see that we get exactly the same result as above. So basically we are still running the same query, but now we are formatting it a little bit better here. Next, I will show to you how you can query this data frame 2 using an SQL cell. If we would like to query this df2 in a SparkSQL cell, we cannot actually query it like this. We can try to run this and we get an error. So basically this df2 is not found using this SQL API here in Microsoft Fabric notebooks. But I will show you a trick how you can do that. Let's remove this cell. And actually this code is exactly the same code that we have here, but instead of displaying this data frame, we are creating this temporary view out of this data frame called df2 view. And what this command does, it will create this kind of a view from this data frame that is then available for that SQL API, and we are able to query that using SQL cell. So let's run this code, and this should finish very fast, and now it is done. And then we can add a new code cell here, and now we are selecting everything from this df2 view that we just created there, and now we should be able to query that, and we are able to query that now using this SQL cell. Today we're covering using explode function in Microsoft Fabric notebooks. This video will explain the basics of how to use this function, which is going to be very useful when we move into more advanced topics with notebooks, and cover how to handle and process semi-structured data like JSON files. Like always, all the material related to this video can be found by clicking the link in the description. But now let's go to Fabric. Here I have a blank notebook that we're going to use in this demo/tutorial to demonstrate how to use the explode function. Let's add our first code cell. With this code here, we will generate a new data frame called df1 that has 3 rows of data and 2 columns. We have the ID column, and then we have the values column. And our values column is actually an array. Then we're also creating this kind of a temporary view out of that data frame 1 called df1 view, so we can use SparkSQL cells to query this data. Let's run our first cell here in order us to create that view. And now we have run that cell and also started a new session for this notebook. Next, let's add a piece of code that will select everything out from that view that we just created. And here we can see our data. So basically we have that ID column, then we have these value columns that has arrays in that column. So we have this bit more complex data type here than usually we have in traditional databases. Next, I will show to you how you can use explode function to flatten out this array. So let's do that. And here is the code that we're going to use. So we have the explode function here. So what we are doing here, we're selecting the ID column, and then we are exploding this values array from that view that we have there. Let's run this and let's see what happens. And now we can see that now we have actually more rows than we had in that original data set there. And let's see what happened there. We can see that we repeated each ID the amount of objects we had in each array. For example, with ID 1, we had 3 numbers in our array. And then in this result dataset where we use that explode function, we have ID 1 3 times here. So we have 3 rows for that. And we can see that on each row, we have one of those array values that we had there. So basically the explode function takes each value that we have in the array and adds them to a separate row. But this also multiplies the other columns that we have in the data. This means that we could have a lot of duplicate data in our table that is not optimal in many cases. But we will come back to this in a later episode. Here I have a code that will create a more complex data frame that we had in the first example. We also have this ID column here, then we have a name column, and then we have this nested values column. In that column we have an array, and in that array we have more arrays. So basically we are nesting arrays on top of arrays. And then we're also creating a view out of this data so we can query that using SparkSQL cell. Let's first run this code here, and it has now executed, and then we can show that data frame using a select statement in our SparkSQL cell. And here we have the data, and we can see that now we have these nested arrays, that we have arrays inside arrays. Let's try to do an explode function for this data frame here, and let's see what happens. So basically now we run the explode function to these nested values. And we can see that now our rows have multiplied, but we still have arrays in our data. So we are not entirely flattened out that data frame. And now we have only peeled off one layer of arrays, and now we still have a one layer left. And here I have the query that would actually peel off both of these arrays. So we are using this first query that we had there as a subquery for this. So we are getting this result first, and then we are running another explode function to these values that we are getting out from that first query. Let's run this and let's see what happens. And now we can see that we have even more rows, since now we are flattening out this array as well. But as you can see, now we are having a lot of duplicate data here. We are repeating the ID and name John 4 times here, and the name Jane 3 times, and name Mike 3 times as well. So we managed to flatten this data frame, but now we are getting that duplicate data again here. And now you could be wondering why to do this flattening process, since we can use arrays in our data frame. My simple answer to that question would be that some systems, like very traditional databases, do not support arrays. For example, if we would be delivering this data to some traditional database that doesn't support arrays, then we would need to do something to those arrays before we would be able to send that data to that database. But we will come back to this later in this series. And so far in this demo, we have only used SparkSQL to demonstrate the capabilities of explode function. But now I will show you how you can do the first example by using PySpark. And here I have some PySpark code that will actually do the same thing that we did in the first exercise in this video. So we are creating that simple data frame having that ID and values columns, and then we're displaying that data frame. Then we are using this explode function to explode that values array into value column, and then we are displaying the end result of this operation here. Let's run this and let's see what happens. This should finish really fast, and there we can see that first data frame, and in this second data frame we have that same result that we had in that first tutorial that we did. Today we're covering reading, processing and flattening JSON files in notebooks. Before watching this video, you should be already familiar with explode function that I covered in the last episode in this series. Link to that video can be found in the description. But now let's talk a bit about today's topic. Nowadays, JSON is a very common data format since many APIs offer data in that format, and it is also default input and output format for many systems. So I would say that for a modern data engineer, it is very essential to be comfortable with handling JSON files in data pipelines. In some cases, JSON files can be quite flat, meaning that there are no nested objects or any hierarchical structures in the file, and in these cases, JSON acts more or less the same way as regular flat files like CSVs. However, it is quite typical that JSON file has some hierarchical structure that needs to be processed and flattened so that the data is in more usable format for analytical purposes or compatible with some relational databases that doesn't support complex data types like arrays and objects. For this video, I have prepared a JSON file that we're going to process together so that the hierarchical structure is removed and the data is completely flat in a more usable format for all use cases. All the materials that I will be using in the following tutorial can be found by clicking the link in the description. Let's get started. Let's start from my lakehouse where I have this zoo.json file, where we have the data that we're going to process today. Let's take a bit closer look what we have here. In this file we have one object, and in that object we have this property called zoo, and that zoo is actually an array, and in that array we have two more objects. We have the first object here, and then we have the second object here. Both of these objects represents a zoo. Our first zoo is in USA, California, San Diego, and it has a zoo ID of 1. Then we have the second zoo here that is in Australia, New South Wales, in Sydney. Then in these zoos, we have some animals. In the first zoo, we have animals property, and in that property, we have two objects here. Our first animal in the zoo 1 is the lion, and the second one is the elephant. And then we have a bunch of properties per animal here. We have some characteristics per animal. Here we have information like the diet and the lifespan. And then we have this habitat array that tells in which environment this animal lives. And then we have also some weight information about this animal. We have all of these same properties for our different animals here. And in our zoo 2, we have also an elephant, and then we have a penguin, and also those same properties for those. And one crucial thing to identify here is that we have many arrays here. And good rule of thumb is when flattening JSON files, these arrays should be all in the individual tables. So this means that when we are going to flatten this file, we're going to end up with 3 tables. Our first table is going to be the zoo, our second table is going to be the animals, and then our third table is going to be this habitat table. Because if we don't put these arrays into a separate table, we would be repeating some information on each row multiple times, and that is not the result that we most likely want in the real case. I have also opened this file to my VS Code editor here, so we can check out this file when we are building our notebook and see how we are processing each layer of this file when we move forward with the video. I have this blank notebook here that I have already attached to the lakehouse where I have that zoo.json file. Next, I would like to read in this JSON file and create a temporary view out of that JSON file so we can query that data using the SparkSQL API. Let's add that code here. And now let's run that code. And now we have read in that JSON file to this df-zoo raw and then created this df-zoo raw view that we can now query using the SQL API. Next, I would like to select everything from that view and just display that using this code here, so we can see what kind of data we are dealing with here. And with this code, we have now only selected that zoo property in our JSON, because that is the first layer what we have in our JSON if we take a look at here in the VS Code that. So basically now we are at this layer. So next we would need to move into that layer where we have those different zoos here. So let's try to do that. For that, we're going to need the explode function that we covered last time. So we are going to basically explode this zoo array to different rows. Let's run this and let's see what happens. And now we have 2 rows here. So we have now separated those 2 objects that we have in that zoo array to their individual rows. So this is a good beginning. And also I would like to note that it seems to be that there is some kind of bug going on in the Fabric that I'm not getting the syntax highlight to my SQL statements that I'm usually getting. But let's not allow that to bother us that much. Now, after we have exploded those zoos out to their individual rows, I would like to query out some properties out of these zoos. So let's add a code that would do that. So basically, now we have this query here as a subquery, and then we are selecting everything from the individual objects that we have here. Let's run this query and let's see what kind of result we get. Now we can see that we get more data here. We have now queried everything that we had inside this zoo object. So we have kind of peeled off that object, I would say. And now we're querying this layer here, this zoo layer, and we also have that animals array there as well, as we can see. But since we're trying to get rid of these complex data types like objects and arrays, I don't want to have this animal array in our zoo table. So I would like to create a new table from this zoo data only, and then have that animals data in its separate table. And here I have the code that we can use to query that zoo data to this zoo table. Let's run this and let's see what happens. So we modified this query a bit. Instead of selecting star, we are selecting individual properties from the zoo, like zoo ID, country, and city. And now we have this data, and we have removed that animals data that we are not going to have in this zoo table. So this query would be our first query to create an actual table out of that array, where we have the zoo information. Next, I would like to move one step down, and I would like to get this animal data to its own table. So we would now need to explode this animal array to its different rows. So let's do that. And here I have the query that again uses that same subquery to first explode the zoo, and then after that we are exploding also the animals array to its own rows. And let's see what happens when we run this. And now we can see that we have all the animals in their separate rows, but they're still inside their objects and in one column. That is not the result what we want. So now we would like to select the individual properties out of these objects to their own columns. So let's do that. And here I have the code that will actually get all the properties from that animals out to their separate columns. Again, using that star so we can see how that data will look. And also note that I'm also getting the zoo ID from the zoo level here. And I will now tell why I'm doing that. Let's check out our JSON and I will try to explain that. Now when we are breaking down this JSON to its separate table, so we're going to have the zoo table and then we are going to have the animals table. I'm going to add this zoo ID to this animal table as well, so we can tell to which zoo each animal belongs to. If we don't take this zoo from this level and add that to that animal table, we cannot tell from which zoo each animal is from. So if you know something about the data modeling, we can think about this zoo ID as the primary key of that zoo table, and then it will be a foreign key in that animal table. But we're not going to dive too deep into this data modeling stuff here. Next, let's run this query and see how it looks. And here we have that data. So we have the zoo ID and then we have the animal ID. And here we have all the 4 animals that we have in the JSON. Also, as we can see, we still have some complex data types here. Like we have this characteristics object here that has more information in it. Otherwise, this already looks good. But I would like to flatten out this characteristics object to this same table if possible, and then only that habitat array there I would like to add to its own table. Let's again check out our JSON here. So now we are on this level querying the JSON, and here we have the characteristics property. We would like to flatten out this diet, lifespan, and then all the properties in the lifespan, and then the weight in kilograms for the male and female to this same level as this animal ID, name, and species. And since these characteristics are just objects, if we exclude the habitat, we can flatten out them to the same row with these. And here I have the query that will flatten out that animal data and remove those complex data types. Let's run this query and let's see how does the data look. As we can see, now we have completely flattened out that animal data. And we can see that we managed to get those characteristics to this same level as the other information. But that required some object references here. For example, we are referring to animals, characteristics, lifespan in wild. And then we're creating this column called characteristics lifespan in wild. And that will describe the information that we have in this nested object. And when we take a look at this JSON file here, it is quite easy to understand and that when querying this animals data, we can refer to this animals object here, and then we can refer to the lifespan, and then we can refer to the in wild by using this dot object reference there. And then we are able to get this information that we have here to one single level. And here we have the query for our second table, zoo animals. Next, I would like to create one last table out from that characteristics data using this query here. So again, we have those same subqueries here. So we first explode the zoo information, then the animal information, and then we also explode this characteristics habitat information. And then we're also getting that animal ID, so we know to which animal each habitat belongs to. So let's run this and let's see what happens. And here we have those habitats per animal here. And again, the same thing here, that this animal ID here links to the animal table that we have here in order us to know which characteristics habitat belongs to which animal. Here I have another notebook where I have the code that will actually create those lakehouse tables out of those queries that we defined in that previous notebook. First, we have the code that will read in that raw JSON file to a data frame and then create that view out of that data frame so we can use SparkSQL API to query that. And then we will create a new schema to our lakehouse, and then we will create the zoo table using the query that we created in that other notebook. And then we will create that zoo animals table, and then finally we will create that zoo animal characteristics habitat table. And now we can run this notebook and see what happens. And now our notebook has run and we can refresh our lakehouse. And we can see that we have a new schema here, and under that schema we have those three tables that we just created here. Today we are covering running notebooks in a notebook. There are a few different methods how you can do this, but there are some limitations and differences between these methods that are good to understand, so you can choose the best option for your use case. But now let's go to Fabric and check out these methods there. Here I have a blank notebook that we are going to use to demonstrate the first method of running notebooks within a notebook. We are going to use this notebook to run this other notebook where I have these few cells of code here. In the first cell we take in some parameters, and I have added default value for our param1, and I have enabled this to be parameter cell by toggling parameter cell from this list. Then we are defining this function print this that will basically just print the value that we are giving it and adding this string this is and that value. Then we are running that print this function by using the parameter value that we are passing to this notebook. Next, we are just printing out some runtime context of this notebook, so we get some context information. And in the last cell I have commented out this exit function that would actually give this exit value for this notebook. But for now I don't want to have this exit function to be part of the execution here, and I will reveal the reason for you quite shortly. Now we are back in that blank notebook, and let's add this run magic command here. With this run magic command we can run other notebooks by just specifying the notebook name that we want to run. So if we would run this cell, now it would actually execute that notebook that I just showed to you. Let's see what happens when this executes. We can see that we get all the prints that happened in that notebook to this notebook as well. So we get that function execution there, and it only prints the default value of our param1 since I didn't give any parameters when we executed that notebook. Then we have also that notebook context here. Next, we can modify this run magic command a bit and add this parameter value for our param1. And let's run this and let's see what happens. Now it has executed, and we can see that now we printed out this param value according to our print function that we have here. So now we replace that param value here with the parameter that came out from this notebook. Maybe somebody has already spotted that when we are printing out this notebook context here, our current notebook name is actually the name of our main notebook, not the sub notebook that we are running here. Because basically when we use this run magic command here, this is actually almost the same thing that we would add all of the code inside this notebook to the beginning of this notebook here. So basically these notebooks are using the same execution context, and then we are executing that notebook and the code of it part of this notebook in a sense. So they are running in the same session here. And this is going to be one of the crucial differences between the method that we're covering right now, meaning the magic command run, compared to the other methods that we're going to cover later on in this video. Also, when using this run magic command, like I described, this is the same thing that we would have all of those codes as part of this notebook. This means that if we would use that print this function, it should be available in this session as well when we run that notebook using this run magic command. And let's try to run this and let's see what happens. We can see that we can call this function in this notebook as well now. Personally, I use this run magic command in cases when I want to separate parts of the same notebook to another notebook. For example, in a case where I have a lot of custom-made functions part of that solution and I don't want to clutter my main notebook with those functions. Then I will add those functions to another notebook and then just add this run magic command that points to that notebook and run that before I execute my main notebook. And that is how I can keep my main notebook nice and clean. Also, now let's go back to the sub-notebook and let's uncomment this exit value here. And I can demonstrate what happens when we have uncommented this. Now let's run this code again and let's see what happens when we have that exit value uncommented. Now our notebook has run and we can see that exit value here. But we can also see that we didn't execute this cell here. Because since these notebooks are running in the same context, this exit value will actually exit this notebook as well. So that exit value will stop the execution of this entire notebook set here. Here I have another blank notebook that I'm going to use to demonstrate those other methods of running notebooks in a notebook. And for this, we are going to use this functionality called NotebookUtils that I've already covered in a separate video. I will leave a link to that video in the description below if you want to check that out. In those NotebookUtils, we have these notebook functionalities and there we have this function called run. And with this run function, we can define the notebook that we want to run and the timeout for that notebook, and then we can also pass some parameters there. And now we can run this and let's see what happens. And now we have run that same notebook that we ran previously, but using this different method this time. And now I would like to use this print this function that I have defined inside this notebook. Let's try to run that function in this notebook. And we can see that print this function is not defined, even though we have that function in this notebook. This is because when using this NotebookUtils run command, when running these notebooks, it is not executing in the same execution context as this main notebook. So it will have its own execution context. And we can see that when we open up this notebook log here, and when we are printing out this notebook context, we can see that now we are getting the current notebook name as the sub-notebook name here, not the main notebook name here. And also that same thing is reflected in our exit value, where I'm also adding that current notebook name. And this means that we cannot utilize functions that we have in these other notebooks that we are running using these NotebookUtils run commands. So this is one of the key differences between these two methods when running notebooks. Also, good thing to note here that this exit function here doesn't actually exit this main session here. It only exits the sub-session that we are running there. So this wouldn't stop the execution of this entire notebook, even though we are running that exit function as part of this sub-notebook. And if we want, we can also catch those exit values to variables like this. And there we can see that we are now printing out this exit value that came out from this notebook when we ran that. Also, with this NotebookUtils, we are able to run multiple notebooks by using this run multiple function. For this, we can give this array of notebooks and we can just specify the name of the notebooks here, and then we can run them. And we can also catch the exit values coming out of those notebooks. And let's see how those exit values look in this case. Let's run this. And we can see that both of our notebooks ran fine. And here is the other notebook, the sub2 that we run as our second notebook. And there we have the exit values coming out from those notebooks. And if we would like to parse the exit values here, we can do it this way. So basically we would select this exit value variable here, and then we would select the number of notebook that we're going to get. So basically this is the number 0, this is the number 1, and there are the properties for those. And then out of that we can get the exit val property. And when we run this, we should get this here, and there it is. But we can also utilize this run multiple function in another way. Here is the code that we could use. We can actually specify this DAG and then pass that DAG to a run multiple function. And to this DAG, we specify these activities that are the notebooks that we want to run. And here we can see how to specify these notebooks to this DAG. So basically we give name to our activity. I usually use just the notebook name. Then we give the notebook name here, and then we can give timeout to that notebook, and then we can pass parameters to that notebook, and then we can specify if we want to retry that notebook if we get an error message, and what will be the retry interval in seconds if we get that error. And many of these properties have default values and you don't need to specify them, and these retry functionalities are optional, so basically you only would have to specify the name and the path to be able to use this. But here I'm also specifying parameters for our second notebook as well. And cool thing about this DAG is that we can define these dependencies. For example, I have this sub3 notebook here, and here I'm specifying that it's dependent on these two activities that we're running first here. So these two will have to execute successfully first before we can run this last activity here. Then we can also specify this total timeout for this entire execution here, and then we can also specify how many notebooks we want to run in parallel. And also we can specify this display DAG via graph viz option to be true, so we can get this visualization of our notebook execution. I will shortly show to you how that will look. Also, we can get some exit values out of this execution as well. Let's run this and let's see what happens. And now it is running, and we can see that now those notebooks are executing. And now our first two notebooks are executing, and our third notebook is actually waiting for these two to be executed. And it will run after they have executed. And now those two went fine, and now our third one is executing. And it should be finished quite soon. And now it is done as well, and there is the visualization that I have specified here that I want. And there we can see that we need to first run these two notebooks and then execute that notebook 3. And here is the exit value that we are getting out of this run multiple function this time. So instead of numbers, now we are getting these activity names that we can use to query these individual exit values here. And here is a print function that will get this sub3 exit value out from this object that we are getting as a return value out of that. And we can run this and see that we now have the sub3 exit value that is there. I hope you now have an understanding how you can run notebooks in a notebook in Microsoft Fabric. If you'd like to learn more about Fabric, check out this video next. Now I thank you for watching and see you in that video. Today we're covering fetching JSON data from an API using notebooks. Nowadays, APIs or application programming interfaces are a very common data source for data solutions, and thus I find it very essential that every data engineer knows the basics how to fetch data from an API. In Microsoft Fabric, there are multiple different ways of getting data out from an API, but in my opinion, notebooks are the best tool for this task, since getting data out from more complex APIs with low-code tools like data pipelines can get tricky due to limitations in those tools. So in this video, we're going to use notebooks, but you can leave some comments down below if you would like to see a video where I teach how to fetch data from an API using data pipelines. In this tutorial, we are going to use an open API, so you can follow along with this tutorial with me and learn the basics of fetching data from APIs with paging and writing that data to a lakehouse. The notebook that I will be using in this video can be found by clicking the link in the description. But now, let's get started with the tutorial. The API that we are going to use in this tutorial is going to be the Pokemon API that can be found by going to the pokeap.co. By using this API, we can get out some Pokemon-related data. And there is actually this cool Try It Now feature on this page where we can try out the different API calls to this API using different URLs. And always when you start working with a new API, it is always good to check the documentation first. And with this API, we have a quite extensive documentation that we're not going to go through in this video, but if you're interested, it is good to know that we have everything documented here, and you can check out how to fetch data from different endpoints. And here we can modify this API call here just to use the Pokemon endpoint, and then we can click submit and see what kind of result we get. And here we can see the result that we're getting, and we can see that we have information about different Pokemons here. And we can actually click this view raw JSON in order to see what kind of JSON we are getting out of this. This is just a pretty illustration of that JSON. And with this raw JSON, we get that same information, but in this more text-based format. And here we can see that we have this count, which indicates how many Pokemons we have in this endpoint. And there are 1302 Pokemon. And then we get this next here that we're going to come back shortly, and then also that previous that we're not going to use in this tutorial. But here are the results that we're getting from this endpoint. And we can see by default this only returns 20 Pokemons. And now we can go to Fabric and try to fetch out this Pokemon data by using a notebook. And let's go to Fabric. And here I have a notebook where I have prepared some code that we can use to fetch data out from that API. And for that, we're going to use this pretty standard library in our Python arsenal that is going to be this requests library. And with this request library, we have this get method. And then we can use this get method and basically get data out from this URL that we have specified here. And this URL is actually the Poke API's Pokemon endpoint URL that we also tried out here. So basically, we would be able to replicate the same thing that we just did here by just using our notebook. And then we are going to print out what is the data type of this response that is coming out, and then we're going to print it out, and let's see what happens if we run this. Our run took a few seconds to complete, but now it is done. Basically, we just got this response back from the API, and the response says 200. This means basically that the API call went fine. But this doesn't show us any data yet, even though we printed out this response. It just says response 200. But the data is actually there already. We just need to do a few tricks to get it show up here. And for that, I have prepared this second cell here. This is pretty much the same stuff happening here, but here we are turning this response into a dictionary using this JSON function here. And now we can run this and let's see what happens. And now we can see when we print out the type of this response.json, it is actually a dictionary. And then when we print out this response.json, we can see that data there. We can see that we have exactly the same data we had on that Pokemon tryout page there. We can see that we have the count, and then we have that next and previous, and then we have this results array where we have all the information about those Pokemons there. But yeah, this is only showing 10 Pokemons by default. And we have actually this next URL where we could find the information about the next 20 Pokemons that we have in this API. We can actually modify these offset and limit parameters here in order to fetch all the Pokemon data that we have available. In this next cell, I have done that. So basically, I have defined the offset to be 0 and then the limit to be the maximum amount of Pokemons we have there. So by doing this, we would fetch all the Pokemons that are available in this API using just one API call. And now let's run this and let's see what happens. With this API call, we can see that we're getting way more information out from that API, and here are all the Pokemons that are available in that API. And next we can talk about what if we would like to write this data to our Lakehouse file section. And we can check it out in this next cell that I have here. And with this code here, we would be able to write that data to our Lakehouse. So basically now we would need two other libraries with our request library. We would need this OS library, and then we would need this JSON library. So first we would be doing that same GET request to that Pokemon API and now fetching all the data that is available in that endpoint by using those offset and limit parameters. And then we would convert that response to that dictionary and save it to this data variable. Then I have my Lakehouse path defined here, and then I have this make_dir function from the OS library that will actually create the folder to our Lakehouse if it doesn't already exist. And then we're going to use this with open and just write that Pokemon data to that file path here that I have defined. And we're going to name that file Pokemon.json. And then we're only going to write that results array from our data dictionary to that file. And now we can run this and see what happens. And now it is running. This should be already done. And we can refresh our Lakehouse. And if you're wondering how you can get this Lakehouse path here, you can just click these three dots here and copy the file API path. And then you're getting this kind of a file path here that is basically lakehouse, default, and then files. And after that, you can specify the folder, like I have specified here, where do you want to write those files. But this should be the standard path that is used with the default lakehouse that you have attached to this notebook. But yeah, now in this Fabric DE Series 29 folder, we should have that Pokemon.json, and there it is. And then we can use this next cell to query out that data from this Pokemon.json file. And let's see how does that look. And here I have the code that will basically read that JSON file there to a data frame, and then we are going to display that data frame. And here we can see the data that we have here. So we have only the information that was in that results array there. So we skipped all this metadata information here that is related to the API logic, since we don't really need that. But yeah, here we can see that we have all the information about those Pokemon and their API pages where we could find more information about those. But what if we would like to fetch this data page by page, meaning that we wouldn't fetch all the data in one API call, and we would actually utilize this next page functionality here and loop through the API until we have fetched out all the Pokemons by using this paging feature. Let's check out that next. And because our Pokemon API has this paging functionality, so we have different pages in this API, and this URL tells what is the next set of Pokemon that we have there in the API. Basically, we only have here the set of the 20 first Pokemons that we have available in the API, and this next URL gives us this API call that would fetch the next 20 and so on. And after our next 20 value is null, then we know that there are no more pages left in this API. So that means that we have already gone through all the pages. And now I will show you how you can implement this paging functionality in notebooks in order to fetch this Pokemon data out page by page. And now let's go back to our notebook and we can show us our second cell. Also in this cell, we will be writing this data to a lakehouse folder and using a timestamp in that folder path. And that's why I've also imported this date time here that can be used to fetch the current timestamp that we can then use in our folder path. But basically now we have expanded our code a bit. So we have this base URL and then we have the endpoint, and out of those we are creating this URL from which we are then getting that data out. And then we have this next URL to which we are first setting this URL to be our first value that we start the API calls with. And then we have this basic iterator here that just keeps track how many iterations we have gone through. And here we are creating the lakehouse path using this base path first, and then the endpoint that is Pokemon, and then we have the current timestamp in the file path. So if we would run this code multiple times, all the runs would go to their different folders. So we don't overwrite any data in our lakehouse. Then I have also this make dars here, so it will actually make this timestamp folder because it doesn't exist by default in our lakehouse, and we don't want to get that missing directory error when we try to write data to that folder. And here I have a while loop that will run until our next URL is none, meaning that we don't have any more API pages left. And here I'm just printing what is the endpoint we are getting the data out from and what is the API call index or the iteration number that we are running. And here I have basically the same code that I had previously there, where we just get the data out from the API using the URL, and then we write that data to our lakehouse using that lakehouse file path. But now we are also adding that iteration number to each file, since we're going to write multiple files. Basically one file for one API page that we're fetching. And then after we have completed this, we are going to set our next URL to that next property value out from our data. So we are always setting it to be the next URL that we are fetching, and we are continuing this loop until our next URL is none or null. But yeah, we can run this code and see what happens. And now it will start running, and we can see that we are fetching data out from that API very fast and iterating over those pages that we have there. And now we can see that we are done with this iteration, and we had 66 pages of data there since we began with the 0 here, and we iterated through 66 pages. And now we should have some data in this folder. So let's refresh this folder. And here I have this Pokemon folder, and under that we have that timestamp folder. And here I have all the different pages that we fetched data from that API. Basically here I have all the data that I had in that one Pokemon.json file that we fetched previously, but here we got all that same data out by using this paging feature. And in many real scenarios, you probably need to build your API calls using this paging, since probably most APIs won't allow you to fetch all the data that is available using a single call. So you need to get used to using these kind of paging features in order to fetch data out. Next, I would like to fetch data out from another endpoint in that Pokemon API. And here I have the code that would fetch data out from Pokemon and Berry endpoints. And I have just modified the code that we just saw a bit, and now I have wrapped the logic to this for loop that will actually loop through this endpoint list per endpoint. And then we are fetching data out from both of these endpoints. So basically, first we would go through the Pokemon endpoint and fetch data out from that Pokemon endpoint using this code, and then next we would use that Berry endpoint and fetch data out from that Berry endpoint. And here we are constructing that URL using this endpoint here that will come out from this endpoint array and attaching it to our base URL. So basically, in the second iteration of this for loop, we would attach this Berry after this URL here. And now we can run this code and see what happens. And now it is running, and we can see that we're fetching now data out from the Pokemon endpoint. And here we should be done pretty soon, and we can see that we're done. And then we fetch data out from that Berry endpoint using few API calls as well. And now if we would refresh our Lakehouse folder, we have two folders here. We have the Pokemon and then we have the Berry. And under this Berry, we have the Berry data that came out from there. And now we can read that Berry data that we just fetched from that API using this code here. Also note here that I'm using a wildcard here, which means that we are reading the data out from all of these files here. And the same logic would work for that Pokemon data as well. But let's read that Berry data to a data frame, and then let's display that data here. And let's see how does that Berry data look. And here we can see that now we have the names of berries here, and then we have the URLs for that Pokemon API where we could find more information about those berries. Also, in this example, I just ran these Pokemon and Berry endpoints one by one. If you'd like to see a video where I create a notebook where we can run these API calls in parallel instead of one by one, leave some comments down below. Today we're covering parallelizing API calls with notebooks. In the previous episode in this series, I covered the basic principles how to fetch data from an API using a notebook in Microsoft Fabric. If you missed that episode, the link can be found in the description. In this episode, we are going to expand that topic and parallelize those API calls in order to fetch that data faster. Since parallelization allows us to do multiple API calls simultaneously, which can drastically improve our processing time. In this example, we are going to use concurrent futures library in Python to do the parallel processing. And it is good to know that there are other ways of doing parallel processing in notebooks as well, like using Spark user-defined functions or UDFs that we are not going to cover in this episode. Also, the notebook I will be using in this video can be found by clicking the link in the description. But now let's hop into Fabric and check out how to parallelize API calls. Before we get started with building parallelized API calls, let's just cover a few basic principles that are good to understand when working with parallel processing. Let's start with this very simple Python function that takes in a value and then prints out that value here. And we can call that function using this string ABC here. Let's run this cell and let's see what happens. And here we can see that we just printed out processing ABC, so our function worked fine. Next, let's expand this topic a bit. Here we have almost the same function we had in that previous cell, but now I have also imported this time library here, and I'm using the sleep function there to sleep 1.5 seconds every time this function runs. Now we could try to run this function here in a for each loop and pass this list of letters to that loop. And with this logic, we would process these list items one by one and wait 1.5 seconds each time we process each item. We could imagine that these are some API endpoints or something that we would like to process, and in this case we are processing them one by one. So we wait until the previous one has been completed and then we run the next one. Let's try to run this cell and let's see what happens. And we can see that we start to print those values here, processing A, processing B, processing C, etc. So we are running these now one by one. In the next example here, we are trying to do the same thing, but now in parallel. So instead of running these list items one by one, we would run them in parallel. Let's break down what is happening in this cell. I'm importing this thread pool executor from this concurrent futures library. This concurrent futures library in Python is this kind of a library that allows us to do parallel processing in Python. It has many tools for running parallel processes, and this thread pool executor is only one tool in that arsenal that we can use. But in my opinion, this is a very good choice for doing API calls. And it uses processor threads to run those parallel tasks. And here I have an example how we are going to use that thread pool executor. So this is the way we would call it. So with thread pool executor, and then we define the amount of workers that will be used. So basically this amount of workers defines how many parallel processes we can have, or what is the maximum amount of parallel processes that we have. So in this case I'm defining there to be 2. So in that case we will run 2 processes parallel. And with this code here, we are executing those parallel processes. So basically, we are submitting this function parallel testing for these parallel processes and then submitting that parameter value that is expecting and getting that parameter value from our list there. And then we are saving the return information that comes from our parallel processes to this futures object here. And now let's run this and let's see what happens. And let's pay attention to things that this is printing. And as we saw, we always ran 2 of these same time because we defined max workers to be 2. And that's why we executed these in batches of 2. If we would modify this to be 3, we would execute this in 2 batches, since we would process A, B, C in one batch, and after that, once they are done, we would process D, A, F. Let's run this again and let's demonstrate that. And let's pay attention to print. And there we can see the first batch and there was the second batch. And when building these parallel processes, this max worker count is one of the most important concepts to understand. Because the process will be heavier, more parallel processes you have. So you have to consider what is the CPU you are using to run this and what kind of limitations there could be when you're running this process in parallel multiple times at the same time. In this next example, I want to cover another very important topic with parallel processes, that is error handling. And here I have modified this code a bit and added this value error when we reach the value D there. So here the process would fail when we run into that D value. And let's see what happens when we try to run this code. And let's run this, and now it is running again in batches of 2 and ABC, and there is DC and FA, and we can see that we didn't get an error message when we ran this. And now let's try to understand why we didn't get that error message when we ran this. When we are submitting those parallel processes to this executor, we are not caring about what happens after that, and we don't have any error handlings. So with these parallel processes, it is important to gather information that comes out from the parallel processes and then do some handling based on that. We can do that error handling in a couple of ways. One way would be to check every process after it has run, do we have errors, and then proceed to the next process. Other way would be that we just let them all run, and after we have run them all, we just go through them and see if there were any errors. And that is the method I usually prefer. And here in the next example, I have modified the code a lot and added that error handling there. So here we are giving a return value every time our parallel testing function runs, and we are just saying completed and some value. And then we have that same error here once we reach the D letter there. After we are done with the processing, we are going to iterate over these futures or these processes that we ran with this code. And for that, we can use this as completed function that can be found from the concurrent futures library. And this basically just iterates over those futures or processes that we run there. And then we are checking, did we have any errors there? So we are getting the results out from our processes, and then we are checking, did we have any exceptions there? And if we had any errors or failures there, we will add that to this failed array there. And if we had any failed processes, we will print out those failed processes and then raise a value error so we get a failure to this notebook. And now let's try to run this and let's see what happens. And now it is running, and we will execute them again in batches of 2. And there we can see that we managed to execute this, but we can see that this entire notebook cell failed, and it says these failed with these error messages, and there we are printing that information that D failed. And here we are raising also that value error there so that our notebook will fail and our processing won't continue further in this notebook or in our data pipeline. And now we have gathered the understanding about those parallel processes. And now we can move to the most juicy part of this video and parallelize API calls. And for that API calls, we are going to use the code that we created in the previous video, where we fetch this Pokemon and berry data from this Pokemon endpoint. And then we're going to write that data to our lake house. I'm not going to explain in great detail what this code does, since I already did that in the previous episode in this series. But for demo purposes, let's run this code and let's see how does this process those endpoints. And now it is running, and it starts with the Pokemon endpoint. And we can see that it's processing it very fast and going through the pages in that endpoint. And after it completed the Pokemon endpoint, it started to fetch data from that berry endpoint. But we can see that this process didn't happen in parallel, since it first processed that Pokemon endpoint and then it processed that berry endpoint. And now we would like to modify this code so that it would process those endpoints in parallel without processing them one by one. And here I have a code that would run those endpoints in parallel. Basically, I have wrapped the logic to this process endpoint function. And in this previous example, we just ran these endpoints in this for each loop. And we would need to wrap these into this function in order us to call this function in that parallel processing executor. And to this process endpoint function, I have added to this error handling functionality by using these try and except functionalities here, so that we can do that error handling that I showed you previously and checked did we have any errors in those parallel processes when we ran them. And here we are doing that actual parallel processing, and the max worker count will be actually the length of our endpoint list, which will be 2 in this case since we have Pokemon and berry endpoint. And after we have run those endpoints in parallel using this executor submit function, then we're going to check if we had any errors there during the processing, and after that we are going to have that error handling that will actually fail this notebook cell if we had any errors and throw some messages about those error messages. And now we are ready to run this code, and let's run this and let's see what happens. And we can see that we are running those endpoints at the same time. And we can see that it's running really fast, and we can see that everything went fine and we didn't have any failures during processing. And we can see that all berry pages were processed and all Pokemon pages were processed. And for demo purposes, we can modify this code a bit to throw an error message. For example, add 1 extra letter to this API URL, and let's see what happens if we run this now. It should fail fast. And there we can see that we get an error message that we had some issues with the HTTP connection. Also, when building these parallel processes and fetching data from an API, it is always a good thing to think, are there any limitations on API side that you could, for example, do too many calls to the API and cause some problems. So it is probably good to check API documentation or contact the API owners to know about these limitations and how they could affect your data pipeline. Also, here we are processing those endpoints one by one. Of course, you could modify this code and do it in a way that you would process each call in parallel and maybe increase the parallelization. But that is something that you can try on your own. Also, it is good to know that this concurrent futures library runs in the driver node when you're using Spark, so it doesn't really utilize those worker nodes at all. So you would have to think about what is the size of your driver node in your cluster, since the driver node is going to be the limiting factor how many processes you can run in parallel. If you're using Spark and you would like to utilize more of those worker nodes that you have in your cluster for that parallel processing, then you would need to probably use Spark user-defined functions or UDFs. That I'm going to cover in a later episode. But for now, it is good to know that there are other options for doing this parallel processing than just this concurrent futures library. Even though I think this is one of the best options to use, and it is one of the cheapest if you don't have a massive cluster to do a parallel processing logic. In this video, we're going to check out T-SQL notebooks that enable better and more collaborative development experience for T-SQL developers in Microsoft Fabric. I give a brief introduction to T-SQL for people who are wondering what is T-SQL and how does it compare to SparkSQL that can be also used in Fabric. In a very brief nutshell, T-SQL or Transact Structured Query Language is the Microsoft's extension or variant of SQL, and it has been mainly used in Microsoft products like SQL Server and Azure SQL databases. In Microsoft Fabric context, T-SQL is mainly used with Data Warehouse as the main development language there. It can be also used to query Lakehouse's T-SQL endpoint that is read-only. On the other hand, SparkSQL is part of Apache Spark and is used for querying large-scale distributed datasets. In the context of Microsoft Fabric, this language is mainly used to interact with Lakehouse's Spark API using notebooks and is one of the few supported programming languages there. Both of these SQL variants have their advantages and disadvantages, and also slight differences in their syntax. We're not going to compare these two languages in this video any further, since we're going to focus on T-SQL notebooks. But if you'd like to see more in-depth comparison between them, leave some comments down below. But now let's open up Fabric and check out T-SQL notebooks and what kind of cool things they allow you to do. Now I have a Fabric data warehouse open here, and we can create a new T-SQL notebook by selecting this arrow next to New SQL Query and then clicking this New SQL Query in Notebook. And this will open up a new notebook with a T-SQL as a language. Also, we can do the same thing by creating a notebook and then changing the language to T-SQL here. But yeah, now we can start the T-SQL development work. And since we are now using Notebook for this T-SQL development work, we can also create markdown cells here, which is pretty cool in my opinion, so we can document and comment our code a bit better using this experience. We can also attach data warehouses and Lakehouse's T-SQL endpoints to this notebook and start query those. We have already attached one data warehouse to this notebook, and that was the data warehouse that I used to create this notebook, and that is then automatically attached to the notebook that you create. But to this notebook, we can attach multiple data warehouses or Lakehouse's T-SQL endpoints by clicking this plus warehouse button here. And from this list, we can, for example, select one Lakehouse T-SQL endpoints. As it says here, the type, is it SQL Analytics endpoint or is it an actual warehouse? The difference is that these SQL Analytics endpoints are read-only, but with the warehouse, we can use the entire T-SQL experience when querying those. For now, let's attach an SQL Analytics endpoints to this notebook as well. And now we have attached two endpoints here. And now I can start query the objects like tables and views that I have in these endpoints. We can start from this movies table that I have here in my warehouse. And we can use these three dots to create this select top 100 rows query quite easily. And now the notebook automatically created this select top 100 query that is selecting top 100 rows from this movies table. And now we can run this and let's see what happens. And it is running and we should get the result quite soon. And here we can see the result. So in that table we only had 3 rows, so we were not able to fetch 100 rows since the table didn't have 100 rows. And now we can query our Lakehouse's T-SQL endpoint in the same manner that we are querying our warehouse here. And let's go to our Lakehouse endpoint here and let's find a table to query. And here we have this IMDb top 1000 and let's select top 100 rows from here. As we can see, we don't have that many options here because this endpoint is read-only, so we cannot manipulate the data via this endpoint, and we would have to do that via Spark endpoint and using a regular notebook or some other tool. But we can select these top 100 rows from this table, and this will also create this query for us, and then we can run this and let's see what happens. And we were able to return the data here. And we can see that we have now way more data here since this table has way over 100 rows in it. Also a good thing to note that we have this three-part object reference in this experience. So basically we have the endpoint, then we have the schema, and then we have the object. And this convention allows us to do cross-database queries that we're going to cover shortly. So let's add both of these queries that we just did to a single cell. And now let's run this and let's see what happens. As we can see, we can now only see the results for the first query that we had there. But actually we can see the result for the second query by using this tab here. And here we can select the result for the second query that we have there. So we can have multiple queries in one cell and then have them as tabs in our results. Also a cool feature to point out here that we can use these charts here and visually represent some columns in our data and do this kind of a quick analysis what's going on with our data to get a better idea what we're dealing with here. And we can actually customize the chart here and do a lot of cool stuff by using this feature. But you can explore this feature on your own more closely. Next, I want to talk about these execution sessions and how does that happen in this notebook. Basically, every cell it is its own session, meaning that we cannot reference things that we have declared in the previous cells in the cells after that, because they don't exist outside of that session. Let's try to clarify this session thing with a little example here. Here I'm just declaring one variable called var1 and having a value of ABC for it. And then I'm selecting that var1. And by running this, we should get a result of ABC. So here we declare that variable, and here we are using it as part of our query, and we can see the results of this select statement here. And now if we would like to refer that var1 in another cell and try to run this, it will throw an error because it cannot find that variable because it doesn't exist in the session that this cell is being executed. Also, we cannot execute a cell piece by piece, meaning that if we would execute first this and run only the selected code, and now we have declared that variable and then try to execute this select statement as a separate run here, we would also get that error message. So because every time we do an execution, it is its own session, this means that the variable is only available in that session and will disappear after that. This is a good thing to keep in mind when developing this notebook, so you won't run into any funny situations when you have declared something in the previous cell and then try to reference in that in the later cell, and then that's not available, because now you know how these sessions work here. Next, let's try to do some cross-database or cross-endpoint queries, because it's also supported here. Here I'm querying those tables that I demoed already previously there, that movies table and that top 1000 table. Those are in different endpoints, as we can see from this three-part reference here. So the first is in our data warehouse and the second one is in our lakehouse. And we can run this query and let's see what happens. And we can see that that query ran fine, and we were able to fetch data from both of these endpoints using this same query here. Next, I would like to show you a few more cool things about these T-SQL notebooks. With these T-SQL notebooks, we're also able to save our queries as tables. For that, we need to highlight the section of the query that we want to save as table and then click this Save as Table button here. And this will then open up this Save as Table wizard here, and here we can select the schema and the table name for our table. Let's call this table as table1_test and let's save it to a DBO schema, and then we can click OK, and then it starts to create our new table there. And now it has already created that new table to that DBO schema. And now we can check out our DBO schema under our data warehouse and the table section there, and there we can see the table we just created. We're also able to download the data that we have here by using this download button and download it as CSV, JSON or XML. Another thing that we can do is highlight this query here, and then we have this Save as View button here, and then we can save this query as a view, and then we can write our view name here, view1, test, and then we can click OK, and that will actually create a view out of this query. And now we can see the view we just created here under that DBO schema and under this views folder. And from this view, we can do some more queries. For example, select top 100 rows and run that query. And here is the result from that view that is actually using cross-database or cross-endpoint queries on the background, since this data is coming from two different endpoints here. We have also a possibility to schedule this notebook by using this schedule feature here and define a schedule when we want to run this notebook. Right now I'm not going to schedule this notebook, but this is something that is good to be aware of, that this is a possibility that you can do here in Fabric. Also, another thing that we can do is that we can create, for example, a data pipeline here, and then we can add that notebook to a data pipeline and run that as part of our data pipeline. And that can be done by selecting the notebook activity here in the activity list, and then selecting the notebook that you want to run from the list of notebooks that you have available here. This works with the regular notebooks and T-SQL notebooks as well. By the time of recording this video, this T-SQL notebook is still in preview, and we still have some limitations with this feature here in Fabric. And one of those features is that parameter cells are not yet supported, so we cannot pass down parameters from the pipeline to notebook like we can do with the regular notebooks. Also, the recent run feature is not yet supported, and the monitor URL inside the pipeline execution isn't yet supported, and the snapshot feature is not yet supported, and the Git and deployment pipeline support is not really yet there. I imagine that Microsoft is going to implement it quite soon, but before we get that, I wouldn't recommend to use these T-SQL notebooks in any production data pipelines as part of the solution, because this is quite a big downside that you cannot use version control and deployment pipelines for this feature yet. Today we're covering reading Excel files with notebooks. Excel is a great tool for calculations and analytical purposes, and business people tend to love it. But for data engineers, its file format can be very challenging, since reading it with any other tool than Excel can get tricky. Usually it is good to save an Excel file as a CSV file and then offer it as an input for data engineering solution. However, sometimes this is not possible, and a data engineer must read data from an actual Excel file. For this scenario, there are many tools in Microsoft Fabric like data pipelines and data flows, but in my opinion, the best tool for this task is the notebook, due to its versatility and flexibility that it offers, since it can handle even more complex Excel files. In the next tutorial, I will show to you how to read two different Excel files with different levels of complexity and write the data in them to lakehouse tables. Also, both of these files and the notebook that I will be using can be found by clicking the link in the description. But now let's get started with the tutorial. Here I have an Excel file that we are going to read in to a lakehouse table using a notebook. In this Excel file we have 4 columns. We have this date column, and then we have 3 other columns that we are going to read in using a notebook. Here I have a notebook that we are going to use in this tutorial. And I have uploaded the Excel file that I just showed to you to this Lakehouses file section and added that to this folder called Fabric DE Series 32. And in this folder, this file 1 is the Excel file that we are going to read in first. We are going to come back to this second file shortly after we have handled the first one, because this second one is going to be a bit more complex than this first one. For reading that Excel file, we are going to use this library called Pandas, which is a very popular Python library that is meant for this kind of a data manipulation and exploration. Personally, I don't like using Pandas that much, but for reading Excel files, it is a very convenient library to use. And in this first cell, I'm first importing pandas as PD, and then I'm defining lakehouse path to this variable. And if you're wondering how to get this lakehouse path that I have here, you can just go to your lakehouse and click the folder and copy this ABFS path here, and this will provide you with this path that I have here. Then next we are using this read Excel function from this pandas library. So I'm calling it pd.readExcel, and then I'm providing the file path that I have there, and then I'm also providing the file name. And after that we are going to print the data type of this data frame in order to see that this is actually a pandas data frame and not Spark data frame. And then I'm going to display data so that we can see did we manage to read the contents of that Excel correctly. But yeah, let's run this cell and let's see what happens. This should finish fairly fast since we are not doing anything complex here. And now it is running. And there we have. So we first printed out the type of the data frame. And as we can see here, we have this pandas.core.frame.data frame. This means that this data frame is not a Spark data frame. And we're going to convert this to a Spark data frame shortly. But as we can see here, the data already looks correct. So we managed to read in that data just fine. In this second cell I have here, we are pretty much doing the same thing that we did in that previous cell, but now we are expanding this example a bit and converting that pandas data frame to a Spark data frame using this spark.create data frame that actually can convert pandas data frames to Spark data frames. And then we are printing out the type of the Spark data frame in order to see that now it's actually a Spark data frame. And then we are displaying the data to see that did we manage to convert the data from pandas data frame to Spark data frame, or did it have any errors there. But yeah, let's run this cell and let's see what happens. This finishes very fast, and as we can see, we first had their pandas data frame and then we have a Spark data frame, but the data looks identical, so the conversion from the pandas data frame to a Spark data frame went fine. And that should be a very simple operation, so I didn't expect anything really happen there for the data. Now in this third cell, we are again reading that same file and then converting that to a Spark data frame. After we have converted that pandas data frame to a Spark data frame, we are creating a schema to our lakehouse, and to that schema, we are then creating a table called file1 based on the Spark data frame. And then we are querying data out from that table to see that did we manage to write that Excel data correctly to our lakehouse table. And now let's run this and let's see what happens. I think this will take a little bit longer to run since we are writing data to the lakehouse. And now our cell has executed and we can see that everything went fine and we managed to query our lakehouse and get that data. And if we would check this schema here, we can see that we have this file1 here, which is the table that we just created there using this code here. So now we have managed to read in Excel file and write that to a lakehouse table. But the Excel file we had there was a very simple one, and it was really a walk in the park to read it in and write it to a lakehouse table. Next, let's have a bit more complex example that you could run into when doing a real-world data engineering scenario. Here I have the second Excel file, and as we can see, now we have two sheets in this file. And here we have this first sheet where we don't have really any data, we just have this text, nothing interesting here. And then we have this data 2 sheet here, and on this sheet we have some data, but the data is formatted a little bit differently than we had there. We have there some text before the data, and then we have few empty rows, and after the data we have one empty row and again some text there. And these texts here and the empty rows will actually confuse the Excel function, so we are not able to read this in like we did previously. Let's try to read that file in like we did previously. So we have basically the same code that we used previously there, but now I have changed the file name to be file2 that I also have in that lakehouse folder. And now let's try to run this code and let's see what happens. And we get an error message, some value error here, that we cannot infer a schema from an empty data set. And this was expected. But we would need to actually specify some options for this read Excel function. And if we check out this page that I have open here, we can see that we have plenty of options available for this function to use. And we can define, for example, the sheet name, and do we have a header or names of the columns, etc. That will then affect how does this reader will behave. So we can, for example, skip some rows in the beginning or after the file. And now we would need to use these parameters for our function to define what kind of Excel we are reading, so we are able to read it in correctly. And here I have some code where I have specified some options. For example, I have specified now that the sheet name where I want to read the data is the data2. Then I'm saying that no, I don't have a header. because if we check out the file here, I don't have a header here. And then we can check out some other options that we have here. Then I'm saying that skip rows 3, so we are skipping 3 rows from the beginning. So we are not reading in these 3 rows that we have here. Then I'm saying skip footer, so I'm saying that skip 2 rows after the data. Because if I wouldn't specify these 2 options here, the reader would think that our data begins from row 1 and ends where the data ends, so here. But these are not the data here that we want to read. We just want this table from the middle. Then I'm also specifying these column names to our data. So I'm saying that the first column is date and the second column is col 1 and then col 2 and col 3. And now let's try to run this code and let's see what happens. And it is running and we can see that now we managed to read in that file 2 contents successfully. And lastly, I would like to write the contents of that second file to a lakehouse table as well and then query that. So we can do that with this code here. So basically we have same code here and then we are writing that to that delta table. And this already ran successfully and we should see another table here. And there is the file 2 table. So we managed to read in that file as well and write it to a lakehouse table. Today we are covering Python notebooks. We have had PySpark notebooks in Fabric since it came out, but now we have Python notebooks without Spark as well. Now you could be wondering what is the point of these and why you might want to use these since you can run Python in PySpark notebooks. Well, the answer is efficiency, since using Apache Spark engine for very trivial tasks can get expensive what comes to the compute, and using Spark cluster is really an overkill in many cases. So this feature allows you to save your precious Fabric capacity for some other tasks. This new solution is targeting BI developers and data scientists working with smaller datasets and using pandas and Python as their primary language. But when looking at this feature from a data engineering perspective, there is often a need to do some lightweight code operations in a data pipeline. For example, do some API calls or light interaction with lakehouse objects like files and tables that doesn't require Spark engine. These Python notebooks offer an excellent way of doing those operations. Next, we will go through a demo/tutorial where I show to you how you can use these notebooks to interact with lakehouse objects like files and tables without using Spark. If you want to follow along, the file and the notebooks that I will be using in the demo can be found by clicking the link in the description. Also, after the demo, I will be discussing some of the current limitations with these notebooks. Let's start from my lakehouse where I have this folder Fabric DE Series 33, and in that folder I have this movies CSV where I have few rows of data as we can see here, and I will be using this file as an example how to interact with files and then with tables in this tutorial. And now let's go to our first notebook that I will be showing to you. Let's first start by discussing what is different here compared to the PySpark notebooks. As we can see, the language for this notebook is Python, which is a new option in this notebook language selection menu. And here we have the other options, so we can create a Spark notebook or a Python notebook or a T-SQL notebook. And today we're discussing this Python notebook here. And then we have the option to choose the Python version here. Currently, we only have 2 options here, but I think Microsoft will expand these options in future. Everything else in these selections is pretty much the same as in other notebooks as well. So these are basically only options currently that are a bit different. And then we can connect this notebook to a Python session here by clicking this connect button. And then it will connect it to a Python session and start a compute. And here below the screen we can see what kind of compute it's using. It's using this CPU with 2 V-cores and 60 gigabytes of RAM. And since this is a Python notebook and not a PySpark notebook, we are not going to use Spark to interact with lakehouse files and tables. And I will show you some other ways how you can do that. One good way of doing that is using pandas. And for those who don't know what is pandas, it is basically this Python library that is used for manipulating and transforming data. And it is very commonly used. And here I'm demonstrating how you can use this pandas library to read a file from that lakehouse folder that I just showed to you. And if you're wondering how to get this lakehouse path that I have here, it can be found by going to the folder and then copying this ABFS path here, and then you will get that path that I just showed to you there. And then we are going to use this file path and the file name that I have there and combine them for this read CSV function that can be found from the pandas library. So we are using the file path and file name and telling that the separator is going to be comma. And after that, we are reading it into a data frame and then we are displaying that data frame. Let's run this code and let's see what happens. And now it is running and should finish fairly quickly since we're not doing any complex operations here. And there we go. And there we can see that CSV data that we had in that lakehouse. And next, let's move to our next example. And here I have the same example, but here I'm using this default API path to that lakehouse folder. And how you can get this path is by, again, here going to the folder and copying this file API path. And remember that this path is only to your default lakehouse. So you can basically have multiple lakehouses attached to this notebook, but I only have one. So this is the default lakehouse that I'm using. So it says here default lakehouse. And we can run this code and see that it works as well, and we get the same result. And next, let's move into our third example. And here I will be showing you how you can write that data actually to a lakehouse table without using Spark. So we will be writing data to a Delta table. And now let's check it out, this code here. Now I'm using this Delta Lake library, that is this open source library that is used to interact with Delta tables without using Spark engine. And then we are doing pretty much the same thing that we did previously. So defining the file path, file name, and then reading that to a data frame. And then we are also defining now the table path. As we can see, we have the table folder instead of file folder defined here. And then we are defining the schema name as folder here as well. And then we are also defining the table name. And then we have to define these storage options in order us to write that data to our lake house. And then we are going to use this write Delta Lake function from the Delta Lake library and write that table to that table path with that table name. And also define that we're going to use this movies CSV data frame there. And then we're also defining that we want to overwrite the data and also overwrite the schema there as well. And then we're using the storage options that we defined there in order us to write that data there. And now let's run this code and let's see what happens. It is running, and now we already wrote our data to that Delta table in our lakehouse. And we can check it out, this Fabric D Series 33 schema here, and in that schema we have this movies table. In this next example, I'll show you how you can read that movies table from the lakehouse table section using this same Delta Lake library. So in here, we are doing the same things that we did in the previous cell, but now we're also reading that table using this Delta table function from the Delta Lake library. And here we define the path to that table and also those same storage options. And then we're converting that to pandas data frame. And then we're displaying that pandas data frame that we are reading from that Delta table. And now let's run this code and let's see what happens here. And now the code is running and we are already done. And here we have that pandas data frame that we read from that Delta table. In this fifth example, I'm showing you how you can use this library called DuckDB to query that data using SQL. And this DuckDB is this very lightweight database engine that runs in your application and doesn't require a server. And in this example, we are not writing data, we are only defining those table path and table name in order us to read it, and also those storage options. And here we are basically reading it to a pandas data frame, and then we are just querying that pandas data frame using DuckDB here. And there is the SQL query that we are using. So we're basically defining a new column to that data frame. And then we're displaying that data that comes as a result from this DuckDB query. And now let's run this and let's see how does the data look. So we have that slide data manipulation here, and there we can see that new column. And in this last example, I show you how you can use DuckDB to directly query the delta table. So here I have this SQL query that I have defined, and here I'm using this function called delta scan, and for that I can give this file API path and query that table directly without using that Delta Lake library there in between. But yeah, let's run this and let's see how does the data look when querying it directly, and it looks fine. So here we are also defining one new column to have this very slight data transformation going on there. Next, I want to show you a few other things about these notebooks, like using parameters and exit values with them. Let's first cover here installing libraries. If you have some other libraries that are not yet available, like you cannot import them directly and you would need to install them first, how you would do that? And for that we can use Python Package Manager or pip and have this magic pip command and install those libraries like this. Of course Pandas is already installed, but we can run this and see how does it work. It will just probably tell that Pandas is already installed, and as we can see it says that requirements are already satisfied for Pandas and its dependent libraries here. So it didn't really install anything, but if you have some exotic library that is not yet available and you would like to use it, you can install it with pip. In the second example of this notebook, I'm showing you that you can actually use Spark in this notebook as well if you want. But I don't know why would anybody want to do this, since you can change your notebook language to PySpark and have Spark available there. But this is the way how you could set up Spark to run in this notebook as well. But yeah, I don't really see any point why would somebody want to do this, since we already have PySpark notebooks here in Fabric. In the third example in this notebook, I'm showing you that we can actually use NotebookUtils library in these notebooks as well. And this NotebookUtils library is very helpful library with a lot of utilities that we can use to simplify things when we are creating our code. Also, good thing to note here that these NotebookUtils are still in preview what comes to the Python notebooks. But yeah, if you'd like to learn more about NotebookUtils and how you can use them to get secrets from the key vault, etc., you can check out the link in the description where I have this dedicated video to these NotebookUtils that will tell you basically all the features that we have available there. And in this last cell of this notebook, I'm demonstrating that you can use NotebookUtils to run these Python notebooks as well. So here I'm saying that I want to run this notebook and the timeout will be 90 seconds, and then I'm passing some parameters for that notebook. Let's not run this just yet and check out that notebook first. So here we have that notebook that I would be running there. And here I have first this parameter cell for this notebook. And if you're not familiar with parameter cells, I have also a video dedicated on those and exit values, and link to that video can be found in the description. But yeah, basically you can define parameter cell by clicking these three dots that can be found here and toggling that parameter cell. And if I would toggle parameter cell, then this would be the parameter cell, but I want it to be this one. So we can only have one parameter cell per notebook. And then in the second cell, we are printing out those parameters so that we can see that the values have changed out from these default values. And then I have also defined this exit value for the notebook that will be returned when this notebook has been executed successfully. And here I'm just passing the parameter 2 value to this exit value. So if we wouldn't define any parameters, the exit value for this notebook here would be 0. But yeah, let's go back to our notebook and let's use this NotebookUtils to run that notebook here. And now it is running and we should execute that quite fast. And it is now in progress. And it is almost done, and now it is done, and we can see that my notebook exit value is param2 value that was 999, and here was the parameter value that we defined for that notebook. And here we can check out how did that notebook executed. So here we had that parameter logic, so basically the execution created a new cell under that default parameter cell and reset those variables that we defined in the parameter cell with new values. And here we can see that we are now using those values and also return them. And now I want to discuss this very helpful tip that can save you a ton of time when developing these notebooks. That can be found by going to this edit tab here, and then we have these browse code snippets here. And here we have a lot of example code that we can use. For example, we have here the code how to write data to a delta table, and it can be found here and inserted to the notebook by using this insert button here or copied from here. But yeah, these are very helpful things, and you can browse this through and see what kind of code you can get here. Next, I want to discuss some current limitations with these Python notebooks, and some of these could be already fixed depending when you are watching this video, but currently when I'm filming this there are some limitations. And first major limitation is that we cannot run these notebooks in pipelines yet, but I think this is something that they will fix quite soon. For example, when I try to run that same notebook that I showed to you where we give those parameters, when I hit that run button and try to run this, we will get an error message. And now it is running, and now it already failed. We get this error message that says that Python notebooks are not currently supported in pipelines and the scheduling of them is not supported yet, but they are working on this feature. So I think this will be coming quite soon to the Fabric. And one nice to have feature what comes to these Python notebooks would be, in my opinion, that we could somehow change this computer size that is being used. So we could even have a smaller compute for this, or maybe larger in some cases, but I don't know if this is on their roadmap or not. But let's see. Today we are covering metadata-driven / configurable notebooks. If you'd like to check out other videos in this series, the link to the playlist can be found in the description. In many data engineering cases, you could be processing many files or tables with one notebook, and hard-coding logic for each table or file can get time-consuming and result to a very messy code. For this reason, I love using metadata-driven / configurable notebooks. In a nutshell, this means that I just define a configuration for the notebook, and then I have some type of iterative logic in the notebook that will go through that configuration and then do operations based on it. In my opinion, this kind of approach speeds up the development process significantly, and adding new files or tables to the solution is way easier, since most of the time that means just adding a new configuration item rather than changing the code in the notebook. I know that this concept can be quite hard to understand if I just try to explain this to you with words only, and for this reason, like always, I have prepared a demo/tutorial to demonstrate this concept in action. Also, all the files and the notebook that I will be using can be found by clicking the link in the description. Let's get started. Let's start from my lakehouse, where I have this new folder in the file section called Fabric DE Series 34, and in this folder I have two subfolders, config and source. In the source folder I have two CSV files. In both of these CSV files I just have few rows of data and the header. So these are very simple CSV files. And in this config folder, I have this config.json file, and this describes the data processing configuration for both of those files. So basically, we are describing here what is the file name and what is the destination table for that file. And then we are also telling the write mode. So do we want to overwrite the data when we write it to the table, or do we want to append the data? In this case, I have described that I want to overwrite the animals data and append the movies data. We can see how this works out when we start to build the notebook where we are going to use these configurations. Then also in this configuration folder, I have this other config file that we are going to use later on in the demo, but we're going to check out this file when we are going to actually use it. But now let's go to our notebook. In this notebook, I'm running first this setup cell, and here I'm importing this JSON library that will be used to read that configuration file to the notebook, and then I'm defining some file paths that will be used to read and write data. And then I'm also defining the config file name here. And then I'm also creating a schema if it doesn't already exist, where I will be writing those tables in this tutorial. Also, if you're wondering how to get these file paths here, I have this same lakehouse that I just showed to you as a default lakehouse in this notebook, and we can go to the files folder and click these three dots, and here we can find these paths here. So basically this relative path for Spark is that Spark path there, and that file API path is that first file API path that we have there. But yeah, this is how you can get those paths. But now let's run this first cell here so that we have our setup ready for this tutorial. And in this cell, we're actually reading the configuration file. And now somebody could be wondering why I'm using configuration files and not configuration tables that some people are using. And my simple reason for that is version control. Since using these files and adding them to the version control is way easier than adding data in a database table or a delta table that would be used for the configuration. So I prefer using files. And now we can run this cell and read that file to a list. And we can see that now that configuration is in a list here in the notebook. And we can see that that list contains 2 dictionaries if we are using Python terminology. So we have a dictionary for each file that we are going to process. In the next cell, I'm just demonstrating how we can loop through this list and how we can fetch configuration items from that dictionary and what kind of reference is needed. So basically here we're just iterating over that list and printing some stuff. And as we can see, now we were able to fetch each configuration out from that list by using this simple for each loop. And with this example, I'm just showing you how to get those configuration items out of that configuration. For example, we can get the source file by referring to the source file key in the config that we are iterating over in this loop. But here we can see that configuration printed in more readable format. In the next example, we are expanding that example a bit, and this time we're actually already reading the data using this dynamic file path. Basically, we're getting that file path that we defined in the setup and adding a source there, and also that file name that comes from the config. So we are reading both of these files in this loop when we run that, and then also displaying the data. And just a quick note here, we are not now defining any settings for reading the CSV file since we have standard CSV files. But for example, if we would have a situation that we would have a header in another file and no header in the other file, we could actually have a configuration property that would define do we have a header for the file or no, and then use that property here dynamically to decide do we have header or no. Just keep in mind that I'm using these very simple configurations here in order to demonstrate the concept and not dive too deep into these configurations. But basically this configuration would allow you to build very dynamic notebook. But yeah, let's run this cell and let's see that we can read that data from the CSV files correctly. And there we can see that we managed to read that data well and the data looks good. So everything works so far. In the next example, we are no longer displaying the data, but in this case, we are already writing that data to the lakehouse table. And as you can see, now we are using that write mode property from the configuration when we're defining the mode for our writer. And here we are passing basically the mode append or overwrite. And then based on the configuration, we are doing different operation per file. But yeah, let's run this cell and let's see that everything works. And now our code is done and we can check out that now we should have 2 tables here. And there we have animals and movies tables. And in this cell, we are wrapping our logic to functions in order us to have more cleaner and modular code. So basically here we have 2 functions for reading the configuration and writing data to the lakehouse table. So basically we are just using the same code that we had previously there, but now wrapping it to functions in order us to have more modular and cleaner code here. So nothing magical here, we just like to keep things nice and tidy. And in the next cell, we are using both of these functions. So first we are reading the configuration based on the configuration path, and then we are looping through that configuration list that came as a result from that function, and then we are running in that loop that writes CSV file to LH table using the configuration. And this way we can keep our main logic here shorter. And now let's run both of these cells and see that everything works fine. And again, our code is running and should finish quite fast. And as you can see, now we are processing these files one by one. And imagine if we would have, for example, 500 different files. This would actually take quite a long time. Next, I show you how you can optimize this process by using parallelization. In the next cell, we are again wrapping the logic to the functions, but this time we are actually going to use this concurrent features library. That is this very powerful Python library for creating parallel processing. And I'm not going to dive too deep into this library in this video, since I have a dedicated video on this and how to do parallel API calls using this library. So if you would like to get more of a step-by-step tutorial how to use this library, I would recommend to check out that video and going through that tutorial before continuing with this one. Here we are importing some things out from the concurrent features library, for example the thread pool and as completed, and then again we are having this read config function, and then we are having this write CSV file to LH table parallel function, and in this function we are having this try and except logic here, because the parallel processing really needs this, since we are not running these files one by one. Instead of we are running them in parallel, and we need to have some logic that will handle the errors if we have any. So we are not going to stop the execution immediately when we run into an error. Instead, we let all of those processes run, and then we are going to go through, did we have any errors in any of those file processes? And for that, we have this handle errors function that will actually go through the result of our concurrent features processing and check, did we have any errors, and then print out those errors if we had any of those. But yeah, we will see shortly how does it work. But yeah, let's run these functions so that they are defined, and then let's check out this last cell here. Here I'm defining the config file name, and the reason why I'm defining this config file name here is that I'm going to change it shortly to another config file that has an error there so that the process will fail, so that we can see how does the error handling work. But yeah, basically we're here doing pretty much the same thing, so just reading the configuration, and then we are going to use this thread pool executor that is going to actually handle the parallel processing, and for that I'm defining max workers to be 2. So in this case we are going to have 2 parallel processing running side by side. Also, a good thing to note here about this parallel processing is that it will run on the driver node of your Spark cluster. So basically your driver node CPU is the limiting factor how many parallel processes you can be having at the same time. There are also other ways in Spark to parallelize things, and if you have really big data and you're running this on a huge cluster, I would recommend looking at Spark UDFs or Spark user-defined functions that we're not going to cover in this video. But that is just a tip for you what to look for if you are having way bigger data at your hands. But yeah, with this we are running 2 parallel processes at the same time, and we are executing that write CSV file to LH table parallel function in parallel, and then we're getting the return values out of those executions to this futures object, and then we are giving that futures object to that handle errors function that we defined there. And then we are checking, did we have any errors in those parallel processes. But yeah, more about these things in that parallel processing video that I have linked to the description. But yeah, let's run this and let's see what happens. And now it is actually running those processes in parallel. But with these 2 files, this doesn't really make that much of a difference. But we can see that we processed both of those files okay, and we didn't have any failures during processing. But yeah, now I will show you how does the fail configuration file looks in the Lakehouse, so we can check out that. So in this file I have changed the write mode to this is not a legit mode for these movies files. Remember we had that append mode here in the other configuration file, but now we have this so that the process will fail when it tries to write that data to that Lakehouse table. But yeah, let's go back to that notebook and let's try to run that with that fail configuration there, and let's uncomment that fail configuration and comment that config, and then let's run this and let's see what happens. Now this should fail, and let's see what kind of error message we get here. And we can see that processing okay for the animals file, but then we had some failures, and I have this custom print defined here so that we had an error with movies file. And I have defined the print for this custom error in these functions that I have here. So basically you could change these to whatever you want, but I prefer checking the errors after I have processed all the data sets in my metadata-driven notebook, since in that case we are updating the data that we can update, and then we are just throwing an error message for those data sets that we couldn't update, so that the end users in this case could possibly get already some of the data. Today we are covering handling file schema drift with notebooks. If you'd like to check out other videos in this series, the link to the playlist can be found in the description. In data engineering, it is quite typical that file schemas tend to change. Typically, over time, new fields are added to the source files that are coming in, or in some cases, fields can be removed from the source files. This kind of schema drifts can cause issues with your data pipelines if you are not prepared to handle them in advance. There are many different approaches and school of thought that can be applied to this common issue. In the following tutorial, I will go through some of the typical options that are being used to handle this issue and discuss their strengths and weaknesses. Also, the notebook and the files that I will be using in the tutorial can be found by clicking the link in the description. But now, without further ado, let's go to Fabric. Let's start from my Fabric Lakehouse, where I have created this new folder called Fabric DE Series 35. And in that folder, I have two subfolders, config folder and a source folder. In the source folder, I have these three files, person1, person2, person3.json files. And in the config folder, I have this person config.json file. But we will come back to this config file later on this video, so I'm not going to go through this file right now. But in these three JSON files, I have some data, but there are some differences in these files. And I will show you these files in my notepad. Here we can see the person1 file. As we can see, we have three properties or columns here in this file. We have ID, name, and age. And in the person2 file, we have added this gender property to the file. So we have four properties instead of three that we have in the first file. And in the third file, we have ID, name, and gender. So basically, we have removed the age property from the third file. And now we can use these three files to demonstrate how we can handle this changing schema in our data pipelines. Also, keep in mind that the concepts that I will cover shortly can be applied to different types of files as well. It doesn't have to be a JSON file. I'm just using JSON here because I like the data format, and I think it is very common nowadays, and every data engineer should know how to handle JSON files. And here I have a notebook that I have attached to that same lakehouse that I just showed to you. And we can see those same folders here that I just showed to you. And now we can start running this notebook. And in this first cell, I just have some preparations for this notebook, and I'm defining the source path prefix, that is the Spark API file path to the source folder. That can be found by clicking these three dots here and copying relative path for Spark. And by clicking that, we would be able to get that same path that I have there, as we can see. And then we have this create schema. If that doesn't exist, I have already created that schema, but that will make sure that we create this schema if it's not already there. And then I have this drop table statement that will clean up the situation and drop the table that we are going to use in this tutorial. But now let's run this first cell here and prepare our notebook for this tutorial. And now it is done. And in the second cell, we are reading that person1 JSON file by using this Spark reader that will read that JSON file to a data frame, and then we're displaying that data frame. Let's run this, and we can see that we are able to read that person1 to a data frame. And here we can see that data that we had in that person1 file. So basically the same data that we had here, but now in the data frame format. And next, let's go to our third cell. And here I'm just reading that same person1 data, and then I'm also writing it to this lakehouse table called person, and I'm using the overwrite mode. So if we would have that table there, we would just overwrite that with new data. And now let's run this and let's see that everything goes okay. And now it is running and should finish fairly fast. And now our command has executed, and we can see that we managed to read that JSON data and write it to that lakehouse table, and then read that data from the table. And we can see that the table looks exactly the same as the data frame that we had in that previous cell. So nothing magical happened here yet. And now in the fourth cell, we are reading in that person2 data where we had that extra column gender. And now we're just reading that person2 data to a data frame and displaying that. And we can see that we get that same data that we have in that file. But as you can see, we have now one extra column there. And next we are going to try to put this data to the same table with that previous person data. And for that, we have this fifth cell here. So now we are reading in that person2 data, and then we are trying to write it to the same person table using now append method. So we are not clearing the table, and we are leaving the person1 data there, and we are just appending this person2 data on top of that data. And now let's try to do that, and let's see what happens. And we get this error message. So let's see what went wrong here. So basically we get this schema mismatch, and we can see that our table schema has only age, ID and name, but our data schema that is coming in from that person2 has also that gender. So we throw this error message that we are not able to write that data to that table. And this is a very common problem in a data engineering scenario when a new column is added to a source file. And there are different ways how we can handle this situation and make sure that our data pipeline doesn't break down in this kind of a scenario. And as we can see, this error message already gives us some hints what to do here. It is recommending us to use this option merge schema and setting it to true, which would allow us to merge the schema of the incoming data with the existing data. And in this cell number 6, we are going to do just that. And now I have modified the code that I had in the previous cell and added this option merge schema true to that Spark writer when we are writing that to the lakehouse table. And now we can run this code and let's see, does it work, and are we able to put that person2 data to that same table and display that data? And now we can see that everything went fine. And we can see that now when we are displaying that person data from our lakehouse table, we can see that we have there that gender column. Remember that these 3 rows here came from that person1 file. And we can see that we don't have the gender there because in the person1 file, we didn't have that gender property there. So we don't have those values, but we were able to add that gender column to the table using that merge schema option. And using this merge schema option might seem very convenient, but I want to discuss some issues that you could face when using it this way. The problem of using this merge schema option this way is that if there would be, for example, a mistake in the source system and the file would fill up with just random columns that are not really needed and would have some random data that we are not interested in, they would be automatically added to this delta table and possibly flood that with some data that is not really needed there. But this is just something that you have to keep in mind when using this option, and later on I will discuss some other ways how you could prevent that kind of situation from happening. But now let's move forward with the tutorial. And now we are reading in that person3.json file and displaying that data. And remember, now we removed that age column, so we don't have that age column in this person3, so we are missing one property when comparing this data to those previous person files that we had there. And now let's try to add that person3 data to the same table with that person1 and person2 data without using that merge schema option. And let's see what will happen when we have a missing column and we're not using that merge schema option there. And let's run this code and let's see what happens. And we are going to display the data in that table, and here we have that table. And as we can see, now we didn't need that merge schema option, since missing columns are just fine when considering this append mode. So it will only throw an error if you have some extra columns in your data. But if you're missing some columns, this append doesn't care about that. And if we would add that merge schema option to this, the result would be the same, so nothing new would happen with this code by adding that merge schema there, because it is able to automatically merge schemas without using that merge schema option when there are missing columns and not new columns. And in this cell number 9, we are actually reading all of those person files at the same time using a wildcard. And now let's run this and let's see that we are able to read in all of those 3 files by using this wildcard in the file name. And let's run this and we can see that we were able to read in all of those files. And we can see that this already merged the schemas from those files when reading them. So in this data frame, we have all the columns that we have in those files. And next I will show you how you can extract the schema from that data frame using this .schema here. And by running this, we are able to extract this PySpark schema out of those files. So this struct here basically describes the schema for that data frame. And we can actually use this schema when reading in those files. So we can define the schema in the notebook and tell that we have these columns in our file and these are the data types that we have here. And then we are passing that schema to our reader function to the schema option here. And when we're enforcing this schema and reading in that person1 data, we are already getting that gender column to that data frame that comes as an output from the Spark reader. So it will be null, but it will be already present there. So now we are enforcing the schema when we are reading in the file. By using this schema enforcement, we are not getting some dynamically changing data frames to our notebook processing, since we are already enforcing the schema when we are reading the actual data. And this has some benefits if we don't want to have some randomly changing data frames in our notebooks. And in this next example, I'm just showing you that I'm commenting out that age and reading again that person1 data, and we are not going to have that age column in that data when we read that. And there we can see that now we have only the gender, ID and name, even though in the actual person1 file we have ID, name and age. And next I will show you how you can transform that PySpark struct schema to this JSON schema. And I will show you shortly why we are doing that. And doing that is very easy, and we have just the dataframe.schema.json function here that will actually convert that schema to a JSON object. And let's run this and let's see how does it look. And here we have that same schema that we had there, but in the JSON notation. And in this next cell, I have that same JSON schema here that I just showed to you. And now we are going to enforce the schema by using this JSON schema here. But before we can use this, we have to convert that back to a struct type by using this struct type from JSON and JSON loads, and using that JSON schema in order us to get that PySpark schema that our reader is expecting to have. And I'm just printing out the schema here that we can see that I was able to convert this JSON schema back to that PySpark schema. And now let's run this and let's try to read in again that person1 data. And here we can see that we managed to convert this JSON schema back to this PySpark schema. And here we had that data that we read in by enforcing that schema. And in the next cell, I'm just going to drop our person table so we are able to write some fresh data to that table. So let's drop that table. And now it is gone. And now we are going to come back to that configuration file that I showed to you in the beginning of this tutorial that can be found in this config folder in our Lakehouse. And now I'm just reading in that configuration file using this file API path that can be found by clicking this button here, copy file API path. And I'm just going to print what we have in this configuration file. So here is the configuration file contents. It's a bit messy in this view, so I will show that configuration file in my notepad and tell you what I have there. And if these configuration files and the metadata-driven approach is not familiar to you, I would check out the previous video in this series where I covered them. A link to that video can be found in the description. But yeah, here we have that configuration that we just read to our notebook. And in this configuration, I have properties, the source file that tells the source file from which we are going to read the data. So I have a configuration here for every person file that I have been using in this tutorial. And then I'm telling to which which table I want to write the data. And now I'm going to write all of the data to that same person table. And then I'm telling that I want to use write mode append for every file there. And then I have this schema property here. And in this schema property, I have actually that same JSON schema that I had here in the notebook, but now I have them in this configuration. And in this cell, I'm reading in that configuration file, and then I have this for loop here, where I'm going to write the contents of those files one by one to that same person table in my lakehouse. And before I run this code, I want to point out a few things. So we are enforcing the schema here. So we are using that JSON schema and enforcing it when we are reading in those JSON files one by one. But we are also merging the schema when we are writing that data to the lakehouse tables. And this means that if we would have a new column in our raw JSON files, we would modify the schemas in the configuration, and that way we would be able to add that new column to our lakehouse table. And this would grant us some more control over which columns are added, because the incoming data, when we are reading it, defines which columns we have there, and we are controlling that by using that schema option. And now let's run this code and let's see that everything works fine. And there it is running and should finish fairly quickly. And now it is already done. And in this last cell, we can check out that table and see that is everything all right in that person table. And there we can see that we have all the person data there, so ID is from 1 to 9. Congratulations to you if you watched every lesson and did all the tutorials with me. If you found this video helpful, hit that like button and subscribe to the channel for more Must Fabric data engineering content. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. Also, if you'd like to learn about data pipeline, that is another great data engineering tool in Fabric, you can check out my 3-hour-long masterclass on that tool. Now I thank you for watching and see you in the next video.